I didn't really cue it with the music. Hi. I'm knackered. I'm all into this stuff right now. All the troubleshooting that I've been doing. I had to root through all my stuff and find a new Arduino when I had died. But here I am, listening to the world of the lights. The radioactive sandwich. Two buddies of mine. I gotta cough it out. I gotta do a little bit of coughing and stuff before the stream because they're cutting the grass out here, and I got a terrible allergy for that kind of stuff. As I use my voice today, it's gonna be tough, but we're gonna make some really good progress today. I think we're gonna be able to really knock out a lot of the facets of this project. The stuff that I thought would take a week has been taking a month, but progress. We made a lot of progress, and I think we're down to comparing two signals. So we'll do a little bit of signal comparison, and I think that might clear some stuff up. It's all in the serial printouts. It's all in the serial printouts. Bunch of windows up here. I've rearranged my whole Windows setup so everything is all over the place. I can't wait to start on this new insulin pump. Tide Pool, that's what it was called. Whatever the reporting program is for all the logs and records for the pump. Tide Pool. Who comes up with the names of this stuff? Open source projects. It's all over the place. It really is. Here, I need where's my stream monitor window? There it is. What's up? Nothing's working. How you doing? I have a list of all the keys that have stopped working on my keyboard. Ever since we took everything out and like oiled the springs and everything. As long as their naming is consistent. But I don't want to have to tell people that I'm having trouble with GIMP. Yeah, my GIMP is weird. I compiled it odd. You know? I'm tired on every level. I actually got over that today. I slept 12 hours 2 nights ago. No, 2 nights ago I slept 3 hours, then I slept 12, then I had a normal sleep, and now I feel good. Not at 100%, but who is, right? Welcome to current year. Let's sleep. Hey, you should get some. You should try it. It's good to get. It's what it's. An Opel engine. Depends on the era, I guess. Yeah. I was gonna say German cars they're not that bad, but then I flash back to working on my early 2000s VW, and I literally was hugging the motor, the entire motor, to get at a bolt that was behind it. It was the only way that my arms would fit in, and so I had to pass a wrench from one hand to the other, and every time you got to flip it over, because the wrench head is tilted just a little bit to the side, so it helps you get it a little bit, and then you flip it over, and then it helps you get it the rest of the bit to get like 10 turns on a bolt. There was actually one time that we were trying to release a motor mount. No, it was something with the timing belt. We were doing timing belt in the VW. And because there was another hair in my mouth, because there was the crash structure, the unibody coming through there, the timing belt was right up against it, and we had to get to a bolt that was right in the middle of that crash structure. So, of course, the way you're supposed to do this is by hoisting the motor on one of those little cranes that you kind of put onto the strut or the fender mounts, and then you put you assume the service position, right? So you unbolt part of the front and then swing the whole front out, and you have to drain the coolant and everything, which we should have done. It would have made the job a lot quicker. But we didn't want to do that. So what we ended up doing was moving the motor up, get a quarter turn, down, get a quarter turn, up, get a quarter turn, down, get a quarter turn. It was ridiculous. It's because it's a transverse motor and such a small car, and the whole parts sharing thing that they did that back then. Absolutely ridiculous. Unreachable parts and bolts. Yeah, it's because you need special tools to get to them. Yeah, you gotta buy the special tool, which looks like a wrench that's been run over by a train. And then it perfectly works because they designed it in computers. Yeah, when are you getting that CPAP, Fat? I'm gonna load up on Mio caffeine. Little squirt things. Still waiting on it, yeah. Hopefully soon. Hopefully it's not too expensive. What am I kidding? It's medical stuff. Adhesive medical strips. A couple weeks? I don't remember it taking that long around here. For my stuff. I don't remember that. Can I curve the edges of that box? Properties. No, I don't have that. Can I add like a filter to it? Filter. LUT, chroma key, color key, crop pad. Crop and pad. Sure, let's try it. Nope, that's not it. That's a bad filter. That just gets rid of part of it. All right, crop or pad is bad. Image mask and blend. Luma key, render to least, scaling or aspect ratio, no. Scroll, no. Sharpen, virtual cam. Okay, I don't like any of those. Mask and blend. What do we got in here? That's not gonna do anything. I need like a corner mask. That's not... I think I need to make something in order to ease the edges. If you have to design tools to work on the car you just designed, you design the car wrong. Listen, where's the car you designed? Where's the car you designed, huh? I don't entirely disagree with you, but there are places in cars where if you have a technician who needs to replace a part that's gone bad, you don't design that part on the outside of the car, like something like a bolt under a turbo for like a heat shield. What if the heat shield eventually rusts because stuff goes wrong? How do you get them to unbolt that heat shield? That's impossible to get to. All right, well, let's design the heat shield on the outside of the car. It doesn't work like that, you know? That's not viable. So you make a tool that looks like a wrench that a train ran over, and then that can get you to the bolt faster and directly instead of having to remove an entire turbo and retune the car and take off the throttle body. You know, stuff like that happens when you have such a complex machine. I'm gonna cough. I mean, yeah, the answer is to not make a heat shield that rusts, but you know, stuff happens. But I don't entirely disagree with you. I definitely don't disagree with you. 10% of true cost because you've already paid $1 billion. Man, I love insurance. I love having a middleman to say no, that I have to pay thousands of dollars before they actually cover any of my medical necessities. It's great. I love the system. It's so good, especially when mankind, or at least America kind, can save billions of dollars with group negotiations. I love employing a bunch of snakes with phones that I get to call and they get to say no. And I love how there are doctors who are not my doctors who are determining what medications I should get. That's great. I really like it because they're more callous than my regular doctor, who I've specifically chosen because I work with them very well. None of your issues are space constraints under weird things. Just stupid. Well, yeah, I've been there. I think if we actually like followed the service position, God, I got a huge fingerprint on my glasses right now. Like actually drain the coolant. Because like I'm reluctant to do stuff like that. We didn't want to go find a basin and have to do all that stuff. But it wouldn't have been that hard. It wouldn't have been that hard to do, just to get a basin, you know, drain that coolant out. I think as I get older, I start to trust the some of the systems a little better. I don't know. I need to do a whole round of maintenance on my car. My friends no longer get together to work on their cars, and or they just don't tell me because they hate me. So I've been waiting for something like that to happen. Not specifically, really I've just been lazy, but you know. It used to be I'd set out to like do my own car work, and then one of them would come in at like the 9th hour and be like, "Hey, why don't you use the lift?" I'd be like, "Hell yeah." That just hasn't happened lately. COVID scattered us a little bit. COVID kind of scattered us all. So I haven't had good contact with a lot of people. Now that COVID is permanently gone. This is Radioactive Sandwich you're listening to. It's two buddies of mine. One of them trying to get in here. Trying to get on the show. I don't know how to do 2 mics yet, though. I have to partially remove my front quarter panel to change a light bulb on my truck. Oh, God. That was pioneered by, what generator? The Mini. Isn't the Mini like that? Oh, yeah, I want to play some of his personal stuff. Yeah, let's switch over to that, Bob. Thank you. Yeah, he's been doing some stuff on his own. Zelkovich. Longer jams. Octatrack of Borderlands, it's dual ambient. That's an 11-minute track. I'm gonna have to swap off of that really quick. I'll move this to a new thing. Hold on, I got a cough. God. They just went around and did some of the yard work around here, and it's hitting my allergies just right. Yeah, I've so on my E36 5 Series station wagon, there's plenty of room around the headlights. That's the only place there is room in the engine bay. There's actually quite a bit of room in the engine bay. There's a lot of nice places. When you open up like a Chevy, like an old Chevy, there are just miles on either side of the engine. It's wild how much room there is. No wonder people are putting like 476s in those things. Is that the right thing? It's 470. I don't think it's 476. What is that big? What's a big block Chevy? Big block Chevy 454. Jeez, why do I think 476 is just a road around here? 454 is in there. Damn it. Oh, my head. All right, this is way too ambient. When this guy goes into ambience, he goes way into ambience, huh? Hancock, New Hampshire, huh? Damn, dude. Let's see. Syntax, tropics. I don't know. I haven't had a chance to preview anything. He says he's got like a huge new set that he was looking forward to doing on this show. So. Ooh, all right. What do you guys think of buffalo wings? Are those the most, like, I don't know what you'd call it, Sigma Hunter? They're like the most, they're like the pinnacle of dominion over other species. Because we've got both plant and bird defense mechanisms that we eat. And we're like, tasty. That's really delicious. This thing that birds have evolved in order to keep themselves safe, as well as this thing that plants have, this capsaicin from these plants really works out. 03 Silverado had enough room for a whole additional engine under the hood. Hey, that's a thing. There are 2 engine cars. Yeah, working on my brother's car, his big diesel giant mobile, because he wouldn't get a minivan, right? Instead of a minivan, he gets a car that's basically its own, like, area code. I don't understand it. We grew up with a station wagon. I have a station wagon now. It's too much room for me. I like station wagons because they're ostensibly 100% invisible on the road. They're invisible. I sped by a cop yesterday. I sped by a cop. Or no, that was 2 days ago. 2 days ago, I sped past the cop. It was a place I know where there is frequently a speed trap right in front of a school, and this was in the morning, about school hours, and I blew by that motherfucker, and nothing. Now that's to say the cop was probably reaching for a donut that he had dropped, but the station wagon helps. It helps. I also had a million cars behind me, so they probably couldn't turn out into the lane, but they probably wouldn't have hesitated. School's out of session. Yeah, that helped me too. Details. Titles. This is actually perfect intro music. I like this. Perfect intro music. I can barely hear it, but let me know if there's anything heinous going on in the background of the music. We're doing more programming today. I'm sorry to say, chat. We're doing more programming today. I can't help it. This is something that I've sunk my teeth into, and it won't go away. It won't go away. Well, the school speed signs are still coming on. Yeah, the little bit of rubber ducking I did with you and Pyro really helped, actually. Even though you guys had no idea what's going on, there's zero expectation of anybody knowing what the hell's going on in my program right now. But I found a couple logical errors, and I fixed a couple more logical errors. So I was able to kind of get into a different headspace and figure that out. I can't believe this motherfucker over here sold the piece of equipment that we modified on stream. We had I think it was an Octatrack that he sold, but we put in a new analog thing, and this was before I had the hot air station. We actually had to break glue, which was really nerve-wracking. Yeah, Julian has a buddy who makes wooden cases, and I have one. I have one of those cases. I gave Julian a pretty penny, a very nice looking penny, for that. I have an analog synthesizer case. And so when I clean the docket a little bit, which again, I'm pushing for it, clean the list of projects a little bit, I would like to get to doing some analog synthesizer stuff. I've done a little bit of homework on it. I was hoping that Julian could teach me a little bit about analog synths, and I asked him about that. I was like, hey, a really cool stream would be if I just played the ignoramus and you taught me how to use an analog synth. And he's like, I have no idea either. And I'm like, okay. Fuck. Fucker. So I've done a little bit of homework. But yeah, we'll get Julian in here soon. He's got an idea of a little project, and frankly, we don't really need a project to get him in here. It's good to have a foil on stream. We had the makers of the Octo whatever track or whatever it's called. That's not the right one. Whatever we modified, the producer, the Scandinavian producer of the synthesizer. Why is Scandinavia like making all the electronics that I'm working on lately? Anyway, they were in chat. They were actually in chat for that one. That was a lot of fun. I should make a synth. How would you extend the cutting area of a K40? Okay, so you use 80-20 rail when you want to actually like be able to break it down. Like when the life of the thing is over and you want to break it down and you want to turn it into something else, or you feel the need to constantly do little modifications and stuff, because 80-20 rail comes with that little stipulation that everything is held together with screws. So unless you're using a lot of Loctite and you're locked in on your design, you'll probably at some point, if it's a very active thing and you're moving it around a lot or it vibrates, you'll probably need to go back and revisit those screws a little bit. 80-20 is pretty reliable in terms of keeping together, but that's always a possibility. So 80-20 in a factory setting is like amazing, right? You can like drop a tank on it. Excuse me, hold on. 80-20 is great in a factory setting. You can like drop a tank on it, not much is gonna move. Or you can build a frame out of it and put some motion sensors on the frame because you've got the sliding rail system where you can move stuff around. You should check out Cranktown City. He kind of like in the middle of the muck and the mess of having an outdoor shop, outdoorish shop, basically a shed. He was able to make, first of all, a CO2 laser that worked somehow, which I'm amazed at. I fucking love that guy. And he was able to make an XY table with a Z plate that goes up and down, all just welding it all together. It was pretty cool. Okay, everything dropped out exactly when I dropped out. Boop, beep, bop, bop, bonk. Should probably open the playlist of his stuff. Hold on a sec. We got a music emergency. I need to figure out what to play next. But yeah, so if you want to, I mean, check out Cranktown City. That should fill your head with enough ideas. But making it out of 80-20 is a great idea, because you can do a lot of that motion stuff with 80-20. And if you screw up, or if you want to go another direction with a project, you can. I would 80-20 is a great idea. I'm just putting him in there as sort of the counterexample to what I'm talking about. And with the 80-20 rail, I've done that. I've started to build the Burn the Subs Redux. Decided that I wanted the next hardware form of Burn the Subs to be a complete departure from what we're looking at right now. And so I've reappropriated all of that rail to be an old board stand. So it's one of those things where like maybe you don't have such a handle on where you'll be by the time you finish the project. And so if you have something like that collecting dust, maybe it's a little bit more useful if you can spool the parts into another project. So yeah, I think you're well to look at 80-20 to do that. Maybe not 80-20, maybe you want to use 20-20, the European cheapo equivalent. That's 20 millimeters by 20 millimeters instead of inch and fractal fractions. But yeah, I mean, it wouldn't be too bad to redo all that setup. Aligning the laser is a pain in the ass, but you got to do that anyway, right? So if you can come up with just like a shroud, and then you need to get plastic panels that are going to be block that CO2 laser, because it's extremely dangerous to have CO2 laser backsplash. That's very dangerous. But yeah, you know, just play it safe, get some laser goggles. You can do good stuff. A lot of people do that. I was considering getting one of those because it's like a complete package. And also you need to do the exhaust. That's a very important part, because there's some really, really bad fumes that come off of laser cutting. I was considering getting a laser cutter. I still am, but it's not on the priority list at the moment. Because it would be nice, because I could potentially put it under the table over there. I think they're a little bigger than I thought, and then getting them shipped from China is a massive pain in the ass. That's really, really, really tough, because it's a big tube with a tube inside of the tube and another tube inside of that, and then you've got very precisely aligned mirrors in addition to all of that. Aligning a laser mirror is not a trivial task. It's not a trivial task. I've had to do it once, and I lucked out. Yeah, it's very tough to do. Luckily, my mirrors weren't installed at I mean, like aligning the tube mirrors. A week later. Yeah, that's about right. You pray to every kind of deity that exists. A couple goats sacrificed. Please. Why does the universe hate me? I don't understand. 10 rolls of masking tape. This is why I appreciate diodes. I like diodes. Diodes are so fucking powerful nowadays, though. I can't even believe it. Back in my day, it was like, I want to get a laser pointer that's like powerful. 20 milliwatts is like $100. And you're like, what the fuck? Nowadays, it's like, I want to get like a laser pointer, and they're like, the least I can do is 2 watts. And I'm like, pointer, I want to point. I don't want to blow people's eyes out of the back of their skulls. Like a fucking Retina Destroyer 5000. You want 12 diodes stacked on top of one another? It's for a DLP projector. I'm like, no, I don't want that. I really don't want that. That's a liability. People don't really understand. They start telling you like, hey, get the most powerful laser you can possibly find. They're like, hey, whoa, get the powerful one. Whoa, make it super powerful. It's like, dude, power is cheap now. We have so much power that it is extremely dangerous. Any sort of a reflection, any sort of a slightly less or slightly more bouncy material, and you could be in a lot of trouble, both legally and just with your own body. Dude's getting suntans from fucking lasers these days. That kid who keeps showing up on Reddit with all the blue lasers that go through the lens, and everybody's like, oh my god, it's like a lightsaber. It's like, no, it's a lot worse, man. it's a lot worse. It is a war crime with a handle. No, a laser cutter would be nice though, because then I could do more mixed material projects. I could 3D print and then put wood panels in something, you know? I would very much like to be able to do that, actually, to be honest. Because you could 3D print something in like a silvery material, like that space silver that I have, and insert it into something like on a wooden piece. Yeah, I don't want to have to like shade up for the stream, you know? Wear my laser goggles and my clean suit. Tyvek. Anything under 10 by 10. Yeah. Yeah, that would be nice. You know, space is the enemy around here. Yeah, Jules' side project has a bunch of these little videos where he does stuff. Pretty cool. Electron. He does have longer mixes. He's just, you know, he only just started this stuff, so. Now that school's out, he's suddenly got a lot of time on his hands. Well, I want to start looking at this thing. I want to start actually working on this thing. I know I started a little bit early. We just have a lot of work to do, and it's gonna be one of those streams. I think I'm gonna be dyeing my mouth red with this fucking shit. I just got one of those little like squirty things, little red squirty things. They're called mice. I mean Mio, because it's apparently got a lot of caffeine in it. But I've had a little bit of it, and I can still taste it, which probably means that I've dyed my entire mouth red. So we're gonna have like gross red mouth bother today. I'll stay down here in the little tiny window. What's up, Pyro? Yeah! As little as I want to actually work on this thing, I think we need to get to work. I already blew up a teensy. Let's just get started. How about we just get started? How about I just I need to keep this for later. I'm gonna pause it. All right, what's going on here? You guys go back over here. This thing comes over here. Boy howdy. Boy, howdy, are we gonna have fun today? Punch it, yeah. Pinch it? I could get in a lot of trouble for that. I don't know why that 6 terabyte hard drive makes so much noise over there. Maybe it's just because the rest of the computer's so quiet. Hi! So we're still here. We're still here working with this stuff. I've made a lot of progress. I've gotten to the end of the sequence where we can start hitting buttons on this thing. However, it's still not kind of happy with us. The Bluetooth device doesn't exactly connect, and we need to make it connect and stick. We got it to connect and stick before, so it's just a matter of tweaking something. There's probably just a value that's wrong. I found a couple mistakes when I was going through the code earlier. I had some major mistakes that I corrected thanks to the help of my rubber duckies in Discord. However, there's still something going on. Oh my God, we'll have to get to the bottom of it. I had a sandwich that had bread with a lot of poppy seeds on it. I don't know what hits so differently about bread with poppy seeds. And it's not just the fact that I'll test positive for drugs now because of the poppy seeds. It's something else. There's something else, some other quality to it that makes it like, I don't know. But I'm gonna burp pretty hard with it. I think it's also the fact that the the sandwich had some kind of like really spicy salami on it. Maybe that's the big thing that hits really hard is the spicy salami. Probably shouldn't eat stuff like that directly before stream, but it's not my fault. It's completely my fault. Anyway, yeah, let's take a look at some of this stuff. Let me explain the project. How about that? Probably should explain the project first. So here we are in my shop. Welcome to my shop. This is where I mop daintily. I gotta tighten the camera a little bit if we're gonna do this. There we go. Okay, so yeah, my steering wheel. This all starts here with this wheel. You see, back in the day, I was playing My Summer Car, and I was going, you know, it'd be a lot easier to control if I had a force feedback steering wheel. So I go online and I look at the prices for like a Logitech steering wheel, and I'm like, that's too much. That's too much. I wonder if there's anything better than this thing, though. I look around, and it's like direct drive steering wheels. I'm like, all right, that's pretty cool. How much do those cost? And it's like, holy, whew. So I took a step back and I said, you know, what if I made my own? What exists? And so I found the Open Wheel project. And the Open Wheel project is a project what allows you to make an open source three-phase motor controller, three-phase servo motor controller. There's a sensor on that. That allows you to have like high quality force feedback. It's basically the electricity goes directly into your weak skeleton body. And so the direct drive force feedback steering wheel has that Open Wheel project. And I'm like, well, this is kind of like a ragtag project. I didn't really find a whole lot of data about it, but I guess I could get into that eventually, right? I found a Mercedes S-Class steering wheel after a little bit of searching, and I was like, this is cool. This has paddles on it, so I don't need a shifter. I've got all these buttons to access to do all kinds of cool stuff. So I bought this wheel, and it's been sitting for years. I bought this motor. It's been sitting for years. I bought the stand for this thing from a Scandinavian company. It's been sitting for... Well, everything here has been sitting for years, but I mean, these more so than the other parts. So this is an old joystick mount for a dual joystick setup that I upgraded. Use the old one to mount the wheel. Great, perfect, amazing. I got from some car buddies of mine an E46 M3 Steptronic shifter that does the up and down kind of rally shifting thing. And then I found the Open Wheel project, and that's the board sitting behind the board. That is the Simucube. The Granite Devices Simucube, what uses their universal motor controller board. So the motor controller board allows me to use any motor that I want as long as I characterize it properly, aka find out all the properties of the motor, plug them into that device, plug the device into the motor, get some force feedback going, a little sensor right there, and then it is able to take this as a gaming input and a force feedback device. Pretty cool, pretty expensive. But I got it all together. And we got it all wired up. And then in order to use all of the buttons on this thing, we had to reverse engineer and decode the digital moon speak that this wheel actually spoke. So this wheel actually speaks something called the LIN bus, the local interconnect network bus. So that's pretty cool. We were able to decode that, and then we put all of the button presses into a little port expander so that it would pretend, even though it's digital, it would pretend to flip analog buttons, basically connect them to ground. And that's through these Ethernet cables on the side of the thing. 'Cause typically with a sim setup, you've got a bunch of devices that plug in with Ethernet cables because they're cheap, and they carry a lot of wires. So you plug that in, you plug it in the thing, you got a bunch of buttons, you don't really need to worry about it. Well, my buttons are all digital, and we made all of the accessories for this thing digital. The pedals, the shifter. You can see this isn't the Steptronic shifter. So what happened over a course of playing My Summer Car a little bit is that I won the rally. I won the rally, but at what cost? I discovered that it was actually very difficult to figure out that Steptronic shifter. So I wanted to have a gated shifter. Well, the cheapest way for me to do it probably wasn't to 3D print it, but it seemed like at the time the cheapest way to do it was to 3D print something. So I custom designed this little jabber right here back when I had clear purple filament. I should probably reprint that in like red or something. The purple's a little weird with the rest of the system. But anyway, we put together this shifter, and we made it feel as close to a car shifter as we could. And it's actually very close. According to my car buddies, it's very close. The only thing is it's a little loose on the side to side. I need to maybe put more angry springs in it. We made it into a LIN bus accessory, as well as the pedals themselves. Pedals themselves are actually out of a BMW too. Both of these upgrades came at the same time. The problem with this upgrade is that now I have so many buttons that I don't have enough to put it on the port expander. There are not enough ports on the port expander. In addition to that, the port expander represents the maximum amount of switches that you can connect to this thing. It's not a lot. There is another way, though. You can buy a Bluetooth low energy module from the company that's configured by the company. Hold on, I'm going to burp. Oh, jeez. Okay. You can buy a Bluetooth low energy module that is configured by the company, built by the company, and sold by the company to other companies that you then buy it from, that will allow you to plug 24 buttons into the device, and it'll digitally speak to the remote battery-powered wheel in order to give you more buttons. But I didn't want to spend the money on a wireless wheel module, so I decided to reverse engineer it. In order to do that, I bought the wireless wheel module, so now we can sniff in on the serial communications. We can pretend that we are both the thing plugged into the base station and the wireless wheel module, and we can become wireless wheel module, and we will have 24 buttons at our digital expense. I don't know. We can use 24 buttons on the thing. So I have been tirelessly, and for the past 10,000 streams, it's taken over the channel. And I understand that it has, and I'm trying to get over it. We will get over it soon. I promise you this. I've made a lot of progress, but we took a Teensy 3.2, not the one doing the LIN bus stuff, but eventually the one doing the LIN bus stuff is going to do all of this once. But this thing is now plugged into TX and RX on the base station. It's able to sniff in on the packets that run back and forth, and it's able to send signals back. So we are able to emulate this device coming up into functionality. I mean, maybe I could have just sat there and like recorded all the signals going back and forth and just kind of like thrown them out there. But we've had to actually follow a process of signaling in order to get this thing together. It has been a nightmare. You see, most of the time, what people do is they go out and they buy the SI Labs Blue Gecko, and maybe they figure out how to program and configure it. Maybe they just figure out how to interface with it digitally through the serial port, right? They plug it in and they run all the example code from SI Labs, or maybe they figure it out themselves and they throw the right signals in there at the right times. There is an entire piece of documentation for that digital signaling system back and forth, right? 99.99999. In fact, everybody who uses the SI Labs Bluetooth module is interested in communicating with the module, not the module's communications to the external world. So it's seen as kind of a black box where you go, hey, 101, and it goes 110, and you're like, ah, yes, I see what you mean. Nobody cares about why it responds the way it responds, except for us, because we're trying to fake being one. We're trying to get it out of the system. I don't want to have Bluetooth low energy on here. Now I could have probably just made a little interpreter that sort of plugs into this board. Could have made a little thing that plugs into this board and just speaks LIN bus. The reason I can't directly connect the buttons on the wheel, by the way, is that the buttons on the wheel are multiplexed in a very strange way. So I didn't really want to touch that. I didn't want to have to go through figuring out how to make my own multiplexer for those buttons. So I can't plug them. I can't plug the buttons directly into the module without significant circuit board alterations and stuff like that. But yeah, so I don't know. It just seemed like one of the better ways to go at the time was to make a module that speaks to the base station, fools it into thinking that it's a Bluetooth low energy module connecting to a remote wireless wheel, and then pull LIN bus, figure out what buttons are hit, and relay that over. We're close. We're close to getting that to work. Okay, so here's my code. It's 4 pages of and hundreds, and it's like probably 1,500 lines of code. I haven't really done a tally because we're not done. But right now we're struggling adding print outputs to everything in order to get a better idea of what's going on. What I have in another window here, I actually have in this window. This is a logic sniffer. I got a little knockoff, one of those little cheapo logic sniffers, and I'm using Pulse View. This is a saved dialogue that we have between the base station and the module that you just saw. We also have captures of other ones, but we don't have enough like data on those other ones, so they're not as useful. So what we have here is the module talking to the base station and fully getting up to speed, and then getting up to the point where it will accept button inputs, right? We need to make sure that we are emulating this properly. So we need to find the location that we are stuck or whatever's going wrong, and we need to correct that wrong and make it right. So that's where we are with this right now. If we can get this up to speed, I have code in here. Dat Deets, thank you for subbing. Did that get smaller? Wow, it's all the way up there in confusing land. I must be burned as a sub. Well, you got to be patient about that, man. The expectation around here is that I burn subs onto a piece of wood, and I don't know where people get that idea, but I don't know. You guys are starting to really grate on me with this, because I know it's the next project, and I'm working as hard as I can to get there. Anyway, so I'm looking at a bunch of this code. I've got a bunch of serial printouts going on. I'm printing out any packet that we send. We got to cross-compare that with this. Now, the ports, oh god, I can't move it like that. It gets sickening. The logic sniffer has actually been a really important part of this, because we get a context of timing with the logic sniffer. Being able to have it immediately decode the hex, save and recall files, it puts it a little bit above the oscilloscope in this. The oscilloscope is a good quick troubleshooting tool, but this really helps us understand and sort of process what exactly is going on here. The serial signaling is asynchronous. It appears like signals will roll in and they'll collide with other signals. It don't give no fucks, but when there is a signal to reply to, it can sometimes almost immediately reply. For instance, here, it's setting up a characteristic value. The 99 is a get right characteristic value. The way these packets work, by the way, is the first byte is just send. Is it replying from a command, or is it sending a command? So 20 is sending a command. A0 is replying from a command. So 5 is the number of bytes after the addressing data. Then we have a class and an ID. So 99 or 94. 94 is get characteristic value. 99 is get read characteristic value. Or write characteristic value, because it goes write the characteristic value to device with handle 1. And then it says register 15. I don't know what register 15 is. Whatever it's doing is it's writing 010 to it. Now this is little endian. So 010, when you apply little endian, is actually 010 because it's flipped. The bytes are okay. This is a palindrome. The bytes are flipped. They're flipped around. They're not flipped. The bytes in and of themselves aren't flipped, but the ordering of the bytes is flipped. So for instance, over here on the characteristic value button press, which is number 11, we have over here, this is doing something else. What is this doing? It's not, there ain't no button press. Oh, here we go. After the 4. So register 4, I guess, is button press. I don't know. But then we have 0, 0, 0, F0. So that's F0, 0, 0, 0. And that represents 24 buttons. 4 and 4 is 8, 16, whatever the next number, 24. Anyway, that's that, right? So that's how these packets are structured. So when I'm jumping through really quickly and losing everybody in the conversation by going, oh, that's this packet, it's because I'm looking at this and this right here, the 0, 1, 2, and 3rd, the second and third byte is telling me what that packet is doing. That's just the way it's structured. I've been working with this API for like 4 weeks. I've just got it memorized. I'm sorry. all of the cross-referencing and the referencing is it just gets out of hand. Okay, so 9. Anyway, so we need to figure out where we're stuck. Now, according to the serial print, by the way, I killed a Teensy 3.2. I murdered it. Teensy 3.2 is the microcontroller platform that I've been using for this project. The 3.2 is an update from the 3.0. I don't know how much difference there is between the 3.0 and the 3.2. I forget. It uses the same chip. I think it's just like little trace layout changes. I have 2 3.0s. I have a bunch of 3.2s. I have been plugging this thing into serial and unplugging it constantly throughout the course of this project, and I've been resetting it a lot. I don't know if any of those have sort of a detrimental effect on the device itself, but it wasn't a USB port error, which is what I expect from USB micro, right? I should probably look to see if Paul's done anything in USB-C, because USB-C is a lot better. USB-C is a much higher, I think, plugging in force, but it's a lot better anchored than USB micro. But anyway, these things will routinely just pop off if they're not properly engineered into the thing, or they're not soldered correctly, which 90% of them are not. But anyway, so during the course of working with this thing, it stopped responding to the serial port. It stopped coming up on the serial port. So I tried a bunch of stuff on the computer. I unplugged it. I plugged it in again. I held the connector in every which position, and it didn't come back up. So I restarted this computer for the first time in like a month. Windows decided to take that opportunity to be an absolute asshole. But it came back up. Computer came back up, and I looked at the serial port, and this thing was connected. So I went to program it, and then the serial port was disconnected, and I looked at everything, still disconnected, unplugged it, plugged it in again, still disconnected. I tried all kinds of wiggling the cable, still disconnected. Unplugged it, plugged the cable in, took a multimeter to the pins on the bottom to figure out whether or not those were connected through the USB cable. They were. Aside from maybe an intermittent disconnect, I don't know what the hell the problem could be. So I think this one is dead. I don't think there's any recovering it. Maybe there is, maybe there's not. Maybe Paul will get back to my email and tell me there's something I can do. I was wondering if he wanted me to send it to him so he could see what's wrong with it and add it to his knowledge base. Anyway, it's a dead chip. Probably throw it away eventually. What do I do then? Well, I had to go and I had to root out some of my old Teensy 3.0s. I don't know what the hell projects these things were plugged into previously. They were configured as joysticks. I was going to desolder this one today and solder some new headers back on it, but nope. So I got this one out. I found this one on the breadboard. I plugged it in. It immediately was recognized by USB. Get a USB A/B switch. I already said that that's not the problem. That wasn't the problem. Why would I fix a problem I'm not having? Works immediately, programs immediately. Had to switch it over to Teensy 3.0. Slight pinout difference, but it's still able to get serial. So I got a serial readout finally, and that burned my entire morning. I was going to try to do some of this stuff, but now we got to do some of this stuff. We got to compare ones and zeros. So I have a Notepad++ document. Let's go over to it. I have a Notepad++ document, and it has all kinds of serial prints on it. Now, I tried to make the serial prints kind of follow a standard, but they're a little confusing to look at. They're a little bit beastly and packed. There's some stuff in it that's wrong. Like, for instance, I probably should have fixed this, but like the reply text should come right after we print out the RSSI. It just means that stuff has been transmitted, right? But yeah, but this TX packet thing is just part of the sender. So whenever we send anything out, it'll say, here's the TX packet that we sent. We don't really need it for the timing information. We know we're communicating that just fine. But whatever, it doesn't matter. It'll just be a little confusing to look at. I've made sure that all of my packets that I'm sending out have TX, RX, or internal in them. So any internal information that I want to know is marked out, or any like timers that are set are internal, stuff like that, like things that are happening inside of the microcontroller that I want to know. So, all right, there's going to be a lot of stuff that I got to get rid of when we finally get this working. Here's what's going on right now. So right now, we're doing everything that we should. And this, by the way, this did not work before last night. Sometime around last night, I found some issues with the logics that I had going into this. Did a few little revisions, a few little corrections, and now it all works. I have, oh my God, I really gotta do the hair day. I don't know when I'm gonna do hair day. If I'm late tomorrow, it means I've gone to the barber shop. So yeah, so what we have here, I know what you're saying. You're just saying it in a weird way. All the stuff that's happening, unfortunately, these prints come before the announcement of what the packets are. That's just the way because I did the easiest thing, which was when the packet gets sent. The way that I had it structured is that the packet gets sent, and then it does the print. And I should have it do the other, I should have it do the packet print after this print. But that means I'd have to edit a whole bunch of functions. So what I did is I just have it printing whatever we send, and then the serial prints will come in later. So it's a little confusing like that. I got kind of confused as to what it was doing because of that. Like, for instance, when it says internal status, that's happening right at the moment. When it says a success packet, that's happening at the right time too. But it's when it's printing the actual values of the packets, that's when it's kind of like out of order. But all right, anyway. So I fixed some logic, which means that we are actually able to get all the way to where we need to go. So what happens is it ends the base station asks us to end the gap procedure. Gap procedure is when any Bluetooth device that is able to announces itself on the network. So it announces itself on the network. It tells us to connect to our device, as in so 1D, 2C, blah, 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 right there, right? It says, hey, connect to that address. And we're like, and then assign it as 1, which it has been assigned to previously. All right, we'll connect to that. So we send, hey, we connected to it, and we assigned it this handle. So our handle's 1. We update our status register, which tells me when to send specific packets, to foo3. Then that triggers 3 packets to be sent. So EVT connection opened. So here's the address again. Connection's opened. Here's the handle, and then I don't know, FF at the end. Should that be FF? Yeah, I think that should be FF. Event connection parameters. So this is one of the ones that we're having trouble with. Connection parameters. This time in the parameters thing, we're sending 1B. So here we are sending connection parameters. We're sending the 1B. All's well and good. Fee status, I don't even know what the hell that is, but it's always this. We send it. All right, cool. So now that we've done all that, we need to set up all of the internal stuff on it, right? Well, we need to say we're done the gap See, it sends the end the gap procedure. I don't want to hear any external devices anymore. And we say, okay, we stopped the gap procedure. This is important because this is what's wrong. It says end the gap procedure, and we say here are no, it says here are connection parameters that I want set. We say, yeah, cool, man. We set those parameters. So we set some statuses there to say that we've done those commands. It tells us to send or start a soft timer of a particular value. Now, this is the keep awake timer. This is what makes sure that your device is still connected. So we send the packet, blah, blah, blah. That, I guess, yeah. So when this is triggered, when this stuff is sent, all this stuff up here, the set parameters, our status goes to this number, F83F. When F83F is achieved, then we send this stuff, and then we update that to F87F so that we don't continue to trigger stuff. Actually, it should be... weird. Why would it go F03F, F83F, F87F? I guess I'm getting my low bytes and my high bytes confused. Either way, it works. Everything works. So, I mean, we get all the way up to FFFF, which means that all those registers have been set. Those are things that I programmed in as statuses. They're just in a 16-bit number. So I probably confused my low and my high bytes, but in spite of doing that, it still works just fine. I made a new register that says that I've set these packets to be sent so that we don't send them a billion times. That's what was killing my program before. So anyway, we have set a bunch of stuff, right? Send a zeroed button packet, send connection parameters, but with an FB in there this time, because last time we sent it, it was 1B. Now it's FB. These are all the little details that you got to get right in order to get this stuff running. Send the GAT MTU, which means that everybody's done exchanging information. It doesn't like this. By the way, look at it, 0A, 0B, right? 0B is one more byte. Haha, counting in hex. 03, of course, is way fewer. Anyway, MTU exchanged, right? That means that everything's done. It doesn't like that, though. So at that point, it goes into sort of an automatic routine. It sets these characteristic values, 15, 17, 15, 17. It keeps doing this, right? 17, 15, 17, 15, 17. I have no idea what they are. I don't know what these are. The way Bluetooth Low Energy works is it's like nested functionality. So you have like the overall register, like with the command and stuff. Then you have like nested registers that have nested registers inside of them. And you can see evidence of that if you're looking through the bytes that are being sent back and forth. And so what we're looking at is one level deep. We're looking at the GAT characteristic value or whatever. They're like things that the controller can do, but we're looking at specific registers of that. We don't know what they do. They're set internally to whatever. I mean, maybe there's a standard for them. I don't know why they chose 11, 15, and 17. We know 21 and 1A represent the battery level and the RSSI level, respectively. But we don't know any of the other ones. We don't know what the values within that are. We know a range. But yeah, anyway, 15 and 17, I don't know what they do. But every time this module connects, they're the same. We get these giant packets that come out of them. And these giant packets, you can see, are counting. So the 17s are interesting. You have 2A number 1 and 2A number 2. 2A number 1 contains 1, 2, 3, 4, all the way up to what 2A number 2 contains, which is, which is, oh yeah, that one starts at 0, which is E, F, 1, 0, 1, 1, etc. Just counting in hex, right? So it's like a whole bunch of data that comes out of this thing. And we have not observed that from our other device. We've only observed that from this device. And people have talked about secret codes and stuff because they like to get too complicated too fast. I don't think we really have that scenario where we have like a secret code that's being shared. Either way, we're spitting all the right data back at the thing, so how does it know? And these are the same value every single time. So I think what happens is it sets stuff with the 15 command, and it checks it over with the 17 command. That's just a supposition on my part. I'm just making stuff up. But yeah, we're spitting out exactly what it wants to hear, and it seems to be okay with it. We send the procedure completed. We receive set characteristic notification 11, which means we're done with the 15s and 17s. So everything seems to have happened properly, right? So it finally sets up the one that we've been looking for this entire time, which is the periodic button task. It then sets up RSSI. It then sets up battery. I have it printing out this data just so that I know. So at that point, there's a couple things that go wrong. First of all, my button press timer is nowhere to be found. It should be setting up a button press, like a periodic button press event, which is something that we can look at and see if it's happening. And then that gets replaced with the actual functionality of the device. We know that our status register is getting to all Fs. That's good. We can check that with just like a simple if statement on the main loop. So in the main loop, we can say if status 1 is equal to FFFF, get the LIN bus, and then write the button packet. That means that we can start actually changing the button packet back and forth. But the thing that goes wrong is that it keeps, there's the button packet zeroed. Add procedure. Set characteristic notification 21. Yeah, 11-1-8-21. So now we're done. We're ready for normal operation. It does a couple timeout events. It says set connection parameters suddenly. Set connection parameters. What is it doing there? We're receiving that. We're sending a packet 941A. So this is RSSI. Because yeah, what happens is we send, yeah, we got your request. Here's the RSSI. Does this packet look right? I think it does. But then it's saying set connection parameters. I don't know what that one looks like, that packet right there. We'll take a look at what it looks like with the other readout. If it looks weird, or if we're sending connection parameters, if we're sending back like a bad packet, it's going to keep trying to configure something, and then it might time out the device and disconnect it. Because that's what's happening. Because then it keeps trying to say stop. It keeps saying command low energy gap end procedure. It did that a while ago. Why is it asking to do it again? It does it again and again and again. So that's where we're running into issue. And that's why I think set parameters is somehow messed up somewhere. So we need to look at all the parameter settings, and then we need to make sure that we're sending back the right data. If I fat fingered a number, or if I got confused as to what I was programming where, that's what's going to mess it up. That's where we are. I mean, it looks like we're sending all the 15s and the 17s properly. So all my code after a certain point is good. We just have to look at some of the earlier stuff to make sure that where it's setting set connection parameters, we're sending the right data back. And it could be one of the other commands too. Why is nothing else highlighting when I highlight that? Copy FV. Yeah, there's other ones in here. So yeah, we need to take a look at those. What? I don't get your joke. I don't get your joke. 15, 17. Command lay connection set parameters. So the successful command gap end procedure. Now, we compare this to a logic analyzer output. So in the logic analyzer output, things are happening a little bit more hectically. We have our gap procedures coming in here, but because it's scanning over the air, there's a lot of Bluetooth devices in addition to just what we have on the desk. All the diabetes equipment that I wear is Bluetooth Low Energy, so that's going to be responding. The computers will respond. The phones. You guys are getting UUIDs that you're not supposed to be seeing here. Horrible things that should be censored on Twitch. But yeah, so all of this stuff comes in. We actually do all this stuff. Command gap end procedure. That's not 8.2. What is that one? So I decided, in a stroke of genius, to call all this stuff exactly the same as it is in the data sheet. That helps me find things. So where is... I don't have the window open right now. That's right, because I restarted the computer. SI Labs, give me your API reference manual. Lend me your manual. Control F. Command gap end procedure. So that's the 3.3 command. 3.3 command. And there's nothing else to it. It's 20.033. It's kind of jarring that it doesn't have any other information on it. It just says, please, for the love of God, stop scanning. It's interesting. If I introduce 2 modules, I probably can't make this part of the individual device procedure. So 20.033. We're starting there. We're starting where it tells it to stop scanning. But it's still a little discombobulated because it actually tells it to stop scanning after it sets up one of the 15s. Right? It actually starts setting something up before it tells it to stop. Here's where it's sending a characteristic value. So 9.9. Here, write this characteristic value to device 1. It starts with a 15. Meanwhile, we have this command coming back. This is a 9.4.1.11. This is a button press. We have a button press and then a 9.9, which is release the gap procedure, meaning we can get other commands. And it's not until all the way out here. Maybe I'm in the wrong spot. Hold on. 9.4.1. Okay, never mind. No. That's well into the 17s. I'm in the wrong spot. Here it is. So this is where it's telling it to stop scanning. 20.033. What is this garbage? So this is a scan result. So it's some other device. 7A, C9, 43D7, etc. to 08. Blah, blah, blah. There's another packet in here. There's a sneaky other packet in this packet. And that would be 80. So this is a... I think it's probably one of the ones that we're looking for. There's an 80, and then there is an 82 with some other properties in there. 1B, etc. And then this thing tells it to stop, and we acknowledge the stop right here, and then it requests 8016, so it's changing properties, or a timer, I forget which one it is, and then we respond to that. So let's figure out where the second part of this is. We're not concerned with the scan response, because in our code, we only respond with one scan. It almost immediately tells us to connect that device and then stop. So 80 would be event low energy connection opened. And that's going to contain all this information, including the handle and the FF at the end. So 8, see, this is why this has been so difficult to do over the past couple of days. 7A, C9, 43, etc., ending in 08. So it pretty much immediately, it's like scanning response from this device, and then in the same sentence it says I'm connecting to it. Man, that's weird. 11FF, okay. Now that's something we send. That's this right here. So then it then sends 8216. 8216 00320001B blah 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 1B0. Yeah, it's all there. I can just look like this. There we go. 1B0, and then finally it sends A028411. All right, so far so good. So according to, and what I'm really concerned with is anything connection parameters adjacent is what I'm making sure we're giving it the right numbers, because somewhere we're not, and that's what's messing it up. I think I'm moderately sure. After that, we need to fix the logic where we don't start, and we don't stop. No, where we don't start sending button presses. All right, next up, I'm gonna scooch forward so I'm actually paying attention. Everybody in the back, wake up. 298160 blah 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 blah. 80. That's going to be the same as this, so that's going to be connection, or open this connection, right? Oh, so let's see. Connection opened. That might be the command gap connect. Command LE gap connect. Hold on, I'm looking for it. We should get the CLID 0800, right? That's what I'm looking for. CLID 0800. We don't have a lot of those, do we? There's a lot of sending that goes on during this. There it is. So, depreciated set parameters. This is the important one. Unfortunately, I don't get a good idea of what's going on there. We just send a success back from that. So, set connection parameters. Sets 32.0 or whatever. 32.0. Yeah, I gotta concentrate on this. Hold on. Because it's all asynchronous, like signals are coming in and going at slightly different junctures. Everything doesn't really follow a set formula, and so I've got to keep it all in my head at once. It's very difficult to do, actually. Oh god, I gotta stop scrolling like that and just click and drag. 81600. So set parameters. That's the 80. That's this guy right here. And then we set a status because we received it. And then because we sent gap end procedure, or we got end procedure, we set that one. Set soft timer 2710. So that's where we acknowledge. And then here we go. 0C 00 is the command, right? That's timer related. Timer related command 10.27.0.0.0.0. So it's setting a timer for, and the handle for the timer is 0. This is all memorization, by the way. This is me having memorized the API because I've been working with it for too long. So handle 0, the timer's set for 0.0.0.27.10.0.0. So 0.0.0.27.10. Oh no, maybe this is something else. Anyway, oh yeah, C0, that's part of the address. Damn it. So it's a timer 0 is set for 0.0.0.27.10. 0.0.0.27.10. Whatever, anyway. Why crappy API? Because it's what the module speaks, so we're trying to become this module. It's actually not that crappy of an API. It's pretty well put together and documented, to be honest. It's really not that ill documented. I would like to see, I would love an actual like readout of like what the procedure is for getting connected, because I don't think I ever ran across like a document that said you need to configure this stuff and this stuff and this stuff in order to get a device up to snuff. I think they probably, for this project, they probably followed an example that had everything done in a certain way, which is probably the best way to do it, because having to learn it in the way that I have, you know, reverse engineering, like I've said, if you want to reverse engineer something, you're gonna have to become an expert in it, more so than the person who engineered the thing in the first place. That's always the case. It's always the case. I always try to not do that, but it's always the case that I have to do that. So anyway, yeah, buddy, we set that timer for you. Once that timer's set, we get a random button press. Now, these are a little bit out of order in this boot. The last time I recorded this, the commands that I'm about to send were all sent at once. For some reason, the way that they're scheduled within the whatever the task manager is of this microcontroller, they come in during the two zeroed button packets. But anyway, we set that stuff, and so our register becomes F83F, which triggers my trap card and sends you to the shadow realm. Basically what happens is the function that I wrote over here, the ready checker, will also check to see if the status equals FO3F. Oh, that's right. Yeah, so I added that register, which turns this into FO3F, and then when I set it, it becomes F83F right here. So what happens is we put a bunch of commands into our command buffer with a little bit of a delay in there too. This one is a multi-command. It has 3 in 1. That way they're all bunched together like they are, like we're about to see. And I could make this resemble that. I could make a different bunch up command and have it actually resemble what we see, but we've also seen the other one and this seems to work. So we send all of them at once as one big block, but we send it after a little bit of a delay. And before that, we send just a zeroed button packet. Then I set the bit register there. So having set the bit register means that, oh yeah, that's down here. Our FO3F becomes F83F. So now that those commands have been added to that register, we receive a set soft timer for 2710. And then we send even before we acknowledge. Wow, so that's right in the middle there. I guess that's okay. But anyway, we receive that timer set up because the SI Labs module has this system by which you can set timers on it. So we acknowledge that later. First we say, hey, we got a zeroed button packet. Wait a little bit. And then we say, hey, we've, in addition to that zeroed, no, we've got another zeroed button packet. Because what happens here, it sends twice. So here's the zeroed button packet. This one is it trying to set stuff up. But here it says, hey, we have another zeroed button packet and another little piece of data at the end. So, all right, anyway. Yeah, it is solidly afternoon for me. How's it going, Mr. Ian? Okay, so blah, 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 zeroed button packet. And then immediately following, we've got 3901 F7s, blah, 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 blah. So, what? Wait a minute, what? Hold on. 1B, 4, F0, A0, length of 3, 9, 0. What the heck is 9, 0? There it is. 9, 0 is GAT MTU. Is that really just called EVT GAT MTU? Let's check on that. I don't know if I need to rearrange the order of that, because if that's like a command that says, hey, we're done doing something, maybe that needs to come in first. Oh, MTU exchanged. I should rename that. I should rename that in my code just for the sake of not confusing myself. So that would be in the TX engine. Find, paste, find. MTU exchanged. Let's add exchanged. There we go. That'll be a little less confusing if I need to do the serial print again. I've not prioritized getting all of my serial prints the same. Schmide at least appreciates having all of this stuff looking nice. I did not stress that. There's a space there. I think that shouldn't be there. Yeah, there's a space that. Oh no, that's not. That's just the kerning, the kenning. But a lot of people, you know, it doesn't really matter that much. People would say to the end result as long as it actually works. And yeah, I would love to be able to do that. You know, min-max my time. But having, you know, correcting stuff with the idea that you're going to come back to it and do something again is very important. I can't just assume that I'm going to get exactly right as soon as we check over our work like I am right now. So I'm cleaning it up as I go and getting all the little mistakes out so that this thing can read properly. What I didn't do is get rid of this thing so that it reads properly, because I'm not going to be printing packets all the time. I want to get rid of all the packet prints, but this was something that I did in order to condense the little serial exchange that goes on to keep the thing awake. Anyway, beep, 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 pop, pop. We were here, 390. So this is where it's sending MTU exchange. Indicates that an ATT MTU exchange procedure is completed. The MTU parameter describes new MTU size. MTU size is 23 before the event is received. So exchanged ATT MTU. Is that like a checksum? I don't think that's like a checksum because it's always F7. Length of 3, 9, 0, 1, 2, 3. So it's 1 F7, 0. And I think one's the handle. Yeah, handle, and then it's F7, 0. And I think it's always been F7, 0. So I don't think I'm getting that wrong. That just says that we can do more commands now. And I think that's it. It's part of acknowledging that 15 command that it got. Every time it gets a 15 signal, by the way, all it does is say, yeah, I got that signal, and then it moves on. The 17s are the ones that have the nuanced replies, and that's why they have a bunch of registers to represent what they are. So 8.2. This is like dizzying. We're getting there though. If I can find what the problem is right now, we will move on from this, and we will be doing more stuff with the physical device. So, and moving blocks of code in and stuff. It'll be a lot more interesting. This is the busy work that we need to do. 821600320. Okay, and that's an FB. FB. Okay, confirmed. So we're a little out of order with these two, but I don't think that's an issue. Programming fascinates me, but I just don't have the brain for it. You know, this is, I'm glad you're fascinated with this kind of stuff. I don't know if I could watch it, but this is less programming and more engineering and reverse engineering. I guess programming is technically engineering, but it's like, I don't know, when you're programming stuff, you're not necessarily doing what I'm doing right now. This is like real annoying stuff. It's mostly because we've dug ourselves into a hole, and that hole is our own API. I think maybe, you know, and we're trying to emulate being something else. If you weren't doing that in a programming project, they're much more interesting. Everything kind of flows a little better. And I know how to do streams with that, and I'm more excited to do those kinds of streams because then we can actually show results of what we're doing. I'm hoping right now we find this issue. I was supposed to find this morning and last night, but you know, I had some trouble with the serial port, and it didn't. You know, I had to move on to new hardware. Okay, anyway, so all that's well and good. There's an animated thing on Twitch that I can't get rid of. This little highlight specific commands message. Always, no matter how much I acknowledge it, it always has this little pulsing dot on it, and I can't get rid of it. I've looked at the whole page up and down. I've changed a setting and gone back, and it just stays. Oh my god. Oh my god, it just moved it to a new thing. What the fuck? It just moved the animated icon over. Ugh. I don't want to permanently delete it. You're like, I'm like, man, this bee is annoying, and you're like, kill the hive. No, I don't want to do that. I don't want to do that. All right, back to our signal. Just for the that's just for the session. Oh, that was a little bit more permanent than that. Okay, so 826032 blah 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 FB0. So we're sending the right one at the right time. This thing tries to set up a characteristic value of 15. We send another button press, and then we send 229900. So, excuse me. So we send all that stuff, right characteristic value 15. We send back we receive a 99. So we said success to 99, and that's what we just got. And then we release the characteristic value. That's what 96 does. It's 392. Oh yeah, 996. Yeah, release the characteristic value. So 96. This is a 99. No, that's EVT GAT procedure completed. EVT GAT procedure completed. This is a 9.9. That's GAT MTU. Weird. I think that's just coming in a weird order. I think that just got pushed out because this thing came in. I don't know. Yeah, because here's the release of the procedure. We do it instantly. They have a big delay in there. I don't think we need the delay because that whole GAT procedure seems to happen just fine. I just want to make sure that our characteristic values are coming through, or our, whatever they are, the connection parameters are coming through properly. And they seem to be. 23.97117. So this would be the first 17. So that would be this one. Read characteristic value 17. Success 9.7. That's what we're sending right here. We skip like a billion years in the future. And then we send a 94117.0. So this would be the first of our 17s. 94117.0B0011. 94117.0B0011. Okay, 96100. 96100. So far, so good. Everything appears to be happening the way it's supposed to happen, which is why I'm increasingly more baffled about what's going on. 599115011. What are we doing here? Ah, that was a setup of 15, right? That's this. Or did we get through that already? Are we down here? I don't know where we are now. Shit, I just lost my place. I lost my place. I think we're at the second. Yeah, we're at the second 15. So the first 15 is up here. The second 15 is here. I have gotten to the point where it's starting to become a second language. 229900 is our acknowledgement of the 15. 9900. That's this one right here. Then we send 39610, and that's release the thing. 391600. This immediately jumps into something that I haven't seen before, which is an 82. Oh, that's this. But we get a read characteristic value 17. One sec. Procedure completed. Read characteristic value 117. But this has already started to reply with 82, which is event connection parameters on the end of that other one. Okay, so we're emulating that. So let's make sure we get the right connection parameters, because I think it's down to these. I think it's down to these not being correct. I'm beeping. Why am I beeping? Oh, Jesus Christ, my glucose level. Give me all of the insulin right now. Okay. This stuff doesn't have carbs in it. It's just that sandwich was too many carbs. If I eat too many carbs, I get stuck in a hyperglycemic rut. Okay, 82, device number 1, 600, I'm reading this right here, 3200, FB 0. Wow, damn it. The damn it part of it is that we're getting it right. Where do I release the get characteristic value? I should probably be putting spaces in this document so that I can see where I am. Because we just sent FB00, and then I have a 97. 229700. What is 97? Do I even have anything that does 97? Yeah, right here. Command read characteristic value reply as a success. Okay, so that is the reply to the command that comes in the middle of this thing. 3971. So it says read register 17. And then this immediately replies at the end of what it's doing. It says, all right, I'll read 17. I got your command. Okay, so that's related to that. This is what I'm talking about with the asynchronicity of the whole thing, is that we'll get commands in the middle of replying to commands, and then it'll immediately reply to those things. And that makes it look like the order is all discombobulated, but it's not. But it's not. And supposedly the Arduino does this. Like, it works like this. Although if we look at ours, it's probably spaced out a lot more. I would like to look at ours, but for some reason this serial monitor, this logic analyzer is a little dodgy. I mean, you know, for $14, I guess I got what I paid for, but that D4 channel will stop working periodically, and I have to like unplug stuff and plug it back in and try again. I don't know what it is. I don't know why that is. Might have something to do with the way that the other Arduino's serial port went out. All right, so far so good. We are, where are we? We responded to second 17 with a 32. But we haven't responded yet. We're here. We haven't responded yet. It takes a little while for some reason to go fetch the register. So our response is, oh no, never mind. We are beyond that. We are beyond that. We are down here. We are down here. Yeah. So we responded with the connection parameters of 32 previously on serial data. 32, that would be this one. 3200 FB. So I got right. It is FB. It says it right there. You can quote me on that. And then down here, we have the response to the connection parameters, 94117. 9411700B 0015. Is that enough zeros? Yeah. Sometimes I like forget the number of zeros or get things like shifted. All right. Next one, 96100. Release the GAT procedure. All right, there it is. GAT procedure completed down here. Okay. We're getting there, chat. I really hope we find a mistake soon, because I'm starting to get a little discouraged. This is just the work. This is the work to get a system running properly. It does another 15 command, and it says 010A. I don't know how that pertains to the specifics of what we're responding with on register 17, because I don't think register 17, if you call for it 4 times, I don't think you're supposed to get such varied data. But I don't know, because it sets up a 15 and then it asks for a 17, 15, 17, 15, 17. I don't know what the deal is. I should probably print out whatever it's looking for on 15. But anyway, 15, 010A. It does this in order. We respond, yeah, of course we got that. We just send this, 229900, right? Cool. Good talking with you. And then a little later on, we reply with 96100, and that's what this one is here. Okay, and that's just releasing the command buffer for another command, which it immediately says, hey, I want 17 again. And we're like, man, you've had enough 17. So anyway, we acknowledge that we got the signal. So that's this. And then success, 97. Then we send this massive goober of a packet. So that massive goober of a packet, let's go through it. A0 31 94117 0B 002A 2A number 1 2A number 1 001. Oh god, I don't want to go over the whole thing. Blah, blah, blah. It ends in 0D. If this is where there's a mistake, I'm going to be annoyed. 1, 2, 3, 4, 5, 6, 7, 8. Why does this program do that? 9. A. B, C, D, 0, and that's the end of it. And then we have a 3961, which is, again, yoink. 3961 is just the procedures completed. Patience doesn't necessarily solve puzzles, but thank you. So that was our read characteristic value 17, number 1. So write 15 and say, yeah, sure, whatever. We zoom out and we get, hey, read 15. We're like, really? Yeah, all right, we'll do that. So we read 15, and then a million years later we say, yeah, we're done with commands. And then it says, hey, I want another 17. And we're like, God damn it. So we say, all right, I heard you. I heard you the first time. And then we give it another massive just crap packet. So 0, 31, 9, 4, 1, 17. I had to make the buffers larger for these, by the way. 17, 0, B, 0, 0, 2A, 2, E, E, F. Okay, so E, F. See, if you got any of these wrong, it would probably kick back something. E, F, 10, 11, 12, 13, 14, 12, 13, 14, 15. We may have to roll back to earlier to see if we get something wrong back there. Because I'm too good at what I do. 15, 16, 17, 18, 19. One A, 0, 2, 1B, 0, 0. That's that packet. All right. So status 1 is that. 39610, 39610. And then we send a blank button packet. No, then it sets up characteristic notification number 11, which is buttons. So success, and then 39610. So it says success, and then it says, hey, you can set up another one if you want. And then it does. And then we get this. What is this? B9411101B. So that's a blank button packet. And then an acknowledgement of 1A. So we send, and we're going to be more clunky with the way we're sending this. It might be that that's the reason why it doesn't trust us, is that our timings are weird. But it seems like this entire system is built for, you know, whack-a-mole timing. So procedure completed, characteristic notification R11, success, we release, procedure completed, characteristic notification 1A. We should send a button packet. Oh, yeah, we should probably send, that's this. Okay, so we send a button packet, but it's after it sets up the other characteristic notification. It's a little late to the party, which I don't think is that bad, because it says like success, and then it immediately sends a button packet. I don't really think it matters if we hopscotch it like this, because otherwise it would be sending this again, and it doesn't. So then it sets up 1A. Let's go back to this. So blah, 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 1A. Release the GAT. I'm being able to read these packets a little too quickly, aren't I? 21, set up the battery notification. Release the GAT. So that's this. Set up the battery notification. Release the GAT. That's a timer expire, which would be this. That's timer expired. Then it says, hey, I would love to hear some RSSI data, 811. It's basically 81 is I would like the RSSI information, and then 1 is the handle for the device. So event hardware soft timer, 0 expires. RSSI request, confirm that we got the packet. So that's 228100, and then immediately reply with the RSSI. And this is just all bunched up for some reason. 8310D9, which is the value of the RSSI. In this case, it's 8310E2. It's just the dBi in a byte. And that's it. That's what it does. Hello. Why are we sitting at an FB? So this might be the trick. After a little while, we're volunteering some information that I didn't know about, which may be why command set parameters is happening, because this keeps cropping up. We received connection parameters. We say success, and we're giving it this data, but I think it might be the wrong thing. 941. What is 82? If I were quizzed on this, I wouldn't be able to identify them directly. Let's see. We're looking for an 08, 02. Eight 4, there's an 8-2. It's not a 20 though, it's a 0A. What is it related to? That's not the right one. 0A, 83, hold on. There it was. 8.2, event connection parameters. So we get an EVT connection parameters in the middle. Why is that happening there? And it's an FB. Is it requesting it right here? Or did I just get confused about where we are? That would be RSSI. 8.3. 22.81. 29.8. Oh, there's all kinds of stuff going on here. All right, we're going to take a look at this in just a minute. I need to use the bathroom, but 8100. Yeah, it looks like there's some more nuanced stuff for us to decode out here. We got to a couple timer expires. Like, that's one timer expiring. And this is all happening as we normally see it. 8311E3 is an RSSI. And then out here, we got some new stuff happening. So where are we right now? We're at like 2 timers expiring. So that would be... hold on. I think that's here. Procedure completed. We're like here. I think something needs to happen here in order for us to properly convince this thing that we're connected. It's weird because we got it into a state before where it was just doing the timer expire over and over again without asking for parameters a lot. But it's unhappy with the way something's set, and so far what we can see is that everything is set the way it should. So we need to emulate some further interactions that are way further down the line that I thought we needed to. So that's where we are. This is progress. We're making a lot of progress, actually. We know that we're doing everything correctly up until this point, except for setting off my periodic button presses. I don't know what's wrong with that loop. But, all right, I'll be back in a sec. I'm gonna put up a BRB and put Julian back on front and center. Set up. My glucose level's high. That means that my kidneys are, like, processing stuff really quickly. BRB. Just pop up YouTube. YouTube. All right, BRB. I'm gonna drink this whole thing in one sitting and my heart's gonna explode. Alright, let's get back to this. Got a lot of intense work to do. Music, stop! It's voice activated. Alright, this goes away. This comes back up. BRB goes away. And I'm back up. Alright, here I am, my extremely active chat. So something's happening right here. Something's happening here. So we have to figure out how we're going to trigger this event properly, because we're out here in no man's land. I don't know what the hell is going on here. I mean, we could add it to the event buffer, but we need to make sure that we are a couple timer expirations. If it expires 4 times, it then asks for the connection parameters. What is this? What is this? So some new stuff is going on out here. A1C00 is timer has expired. 21811 is RSSI, I believe. Here, let's duplicate this. Copy, paste, find 8. We're looking for 2811. 28.1. Command connection get RSSI. And the connection handle is 01. So it's asking for the RSSI, and then it generates an RSSI event. There's a lot of stuff to be happening all at once. 2980. So for some reason, it is then volunteering 9.4, which is what? 9.4 is discover characteristics by UUID. No, it's an A0. Hold on. I can't believe the A0s have completely different identities as the 20s. Usually A0 is a response to something a 20 is asking for. A093. What was the one previous? 94. EVT GAT characteristic value. What value is it responding with? Oh, that's 1A. 9B00, and then there's a 228100. So that would be the acknowledgement of the RSSI request. So this is a 1A. Or a 1B? No, 1A. 1A is the RSSI or the battery. I forget which one it is. But it is replying with a value. This is replying with a value. Now, we have a fixed packet that we've already got that represents that. So that thing should be inconsequential. That is an asynchronous or a triggered event that's coming back from the receiver. We have a timer expire RSSI request, and then the acknowledgement and data of the RSSI. But in addition to that, we also have our RSSI value immediately coming in. We don't need to worry about that. Oh God, I don't even know where we are. We're on like the second timer expiring. All right, so then we get 80 suddenly. 1606. What are you doing? C8. What is an 8? 80. 80. And it's a request. 82, 81, 86. Ah! Saw it. I saw it. Set connection parameters. Okay, so I guess this is normal. So it's actually normal for it to be setting connection parameters out here. Which means we're okay. We're A-okay so far, matey. M80. So everything's fine. We can all go home. There's still a problem, though, because the module doesn't stay connected. So this is a problem. Set parameters. Nine for 124, ba ba ba. I think we still need to reply with the connection parameters, though. And I don't have it printing out what this received packet is, because I don't know if this is unique. C80. So we do this, and then what? C80 FB0 82160. We're not responding with that. That's why it's displeased. Okay. So if we get a connection set parameters and hold on, I'm just looking to see if we get one earlier. Connection parameters there. I think I need to do another setup packet. I think I need to add another thing to the status, which means I need to change a bunch of the statuses. Or I look for status equal to FFFF, and then I continue on. But I guess we just need to do... We need one more. So we need to change the initial F into an E. And I need to set one more. See, I want to know when this whole thing is done so that we can start doing the LIN bus stuff. That's sort of the goal. That's one of the alternate goals here. So let's let me just stretch. Let me just stretch quickly. And let's set up a register for this. So what I need to do is go back to my code. So this is what we're going to be doing. We're going to be piecing through and picking out the areas where it's not working properly and tweaking them just a little bit to get everything up and running. I made guesses, not really guesses, but I worked with the API and what we recorded for most of it, but there are little things like this where we thought things were just rolling along where they're not. So, oh man, this is going to be fucked up. All right, so first of all, I need to add to the end of this. This is specific to the device, right? class method connection handle. Yeah, this is specific to the device. So 12 EVT con parameters, I guess. Now the question is, are these connection parameters different from the other ones that were sent? Well, either way, we need to do a new piece of interaction, which is to respond to it properly. So yeah, so what we need to do is, Jesus Christ, where the fuck was I? Okay, I was here. Jeez, why did that scroll down so far? Connection parameters, HO1, success, 94121B. No, wait a minute. Yeah, HO1, success 80. So we would need to TX con params here. And that needs to look like this. So that would be... Now the question is, the other times that it's been set, let's take a look at where else it's been set. The depreciated set connection parameters, copy, paste, look at it, next. This is the second time that it's ever being requested, huh? Yeah, okay. So if it's already been sent, then we need to send, if it's already been sent, then we need to send the event, right? If it's already been sent, then we need to send back all the parameters. That's how this packet works. So I'm adding it to the device register to mean that we haven't done something yet and we need to do this thing. Otherwise, it's going to continue to request it and it'll time out the device and get all weird. So, my brain. Okay, so we go over to here. We add this extra event, which means that instead of being not F7, instead of being for the device, instead of being F000, it's going to be E, because that last byte is basically 1, 1, 1, 12, 13, 14, 15, 16, 15, 14, 13, 12. So 3 1s and 1 0, and then the rest is zeros. So E, and then all zeros. E. Okay, so that's that. That's gonna, every time I close the module, it'll put it back to that number. Let's see. For our trigger over here, we need, instead of looking for F03, we need to look for E03. And this is the only trigger that's looking for a particular value as far as I know. Let's just check to see where status 1 is invoked anywhere. That's going to be a lot of different places, but we're going to see if status 1... Actually, let's do status 1 with the double equals on it. Status 1 with the double equals is what we're looking for. Anywhere that status 1 is being looked at. That's fine. That one we changed. That's fine. That one we changed. All right, 2 places in there. TX engine. Good. RX engine. Good. This is what I get for referencing direct numbers instead of putting everything in variables. Good. I found a couple mistakes in this thing where I had not put double equal signs on something. I fixed it though, so I think that's good. All right, so we're gonna add another status 1 is equal to, and we're gonna add it in the the depreciated thingy-majig. Connection parameters, yeah. Which I guess is up here somewhere. Every time we're doing EVT connection parameters, we're giving it a thing, which means maybe I need to make a new case for it, because there are times we reply with the connection parameters command LE connection set parameters sets off LE connection parameters. handle, interval, latency, etc. Event LE connection parameters. Oh yeah, wait, no, that's when we, damn it. Okay, sorry, chat. I'm trying to remember how my program works. That's the event. This one is set. What's interesting is that I think maybe this is called multiple times. Maybe I didn't have to do what I just did. (8.0) set parameters, set status 4. It set status 1 to 4, status 2 to 4. That should be happening after I do something. What's happening here? We just send a success. That's it. So now I need something new. Well, that's going to be interesting. That's right, because it's only invoked once. Wait, but I thought there were... Oh, that's right. It's only invoked once, and then there are a bunch of cases where it actually gets thrown out just randomly. So I guess what I'm going to need to do is... So if all this stuff is status 1 of 4, error would go here. Error. Okay, so bit read status 1 12, right? 12. I gotta remember what tab we're in. If that is true, then we need to bold the event. Now, does it acknowledge it? I think it does. Back a million years. 22800, yeah, so it does acknowledge it. 80165, I don't even know. All right, we'll just make sure that we'll send the right packet if we just throw this out here. That I need to add a special event to the event handler. Probably what I need to do. And in fact, I can do that before. I could have it just set that no matter what. It doesn't really matter. But that should probably be if bit read. One of 4. If not, bit read. And it'll just send a success. I mean, like, I could have it set that bit every time and do the check every time, but... I don't even know what that means. It always sends a success immediately. What I need to do is I need to... And that's the response. It should go response and then event. So the response is the immediate result of the packet command. We send it a success code. And then... if the status is of 12 is set already, wait a minute, I don't need a new status for this. I could just say if that's already set. Yeah, I don't need a new status for this. Damn it. All right. Let's turn our E's back into F's. We only need to check the one register because if it's already set, then it'll just blow back a normal. So F3F, and then we need to make sure that when it resets everything, it sets the proper thing. Okay, so yeah, okay, never mind. Because it literally, we get this command twice. So if the command's already sent, and we'll set up a register if we get another one after this. Yeah. Okay, so back to what we were doing. So if bit read status of 12, or no, of 4, else. else we just set the statuses. That's cleaner. Yes, that's exactly what they are. That's why we have an event engine that puts commands onto a buffer and performs them 25-ish milliseconds later, depending on where they're scheduled. I'm buzzing. No, shit's going down. There's a giant fight outside of my house. All right, let's see. So we then send connection parameters. And we're sending FB, if I recall correctly. All this stuff, yeah, we're sending FB, and I'll make sure the other numbers match up too. All this stuff corresponds, all this engine stuff that I built allows us to do stuff like this. Like I can send 12 now, and I can put that into the event register for the handle that's been passed into this device, or passed into this function, and now we can check to see whether or not my loop is stupid. What did I do? Oh. So now we can see whether or not we've gotten connection parameters before. And if we have, then we send this in there. But if we haven't, then we set the statuses of whatever the loop is, and then we get the hell out of there. So the only thing we send is a success if we've got new parameters going in. If they're the same parameters, we need to bump it back. And for some reason, that's been confusing this device. I don't know why. It's just been confusing the device. So let's double check. Double check that we get the right stuff here, huh? Let's see. So we're going to event 12, EVT connection parameters, and the handle's FB. So I'm going to copy this, find it, paste it, find. There it is. That's not it. That's a multi-command. That's another one. It's another one. There it is. See, we've got all these like multi-commands coming in that give it different connection parameters for some reason. I don't know what it's doing specifically. I'm sure it's got a logic behind it, but so A0, A8, so far so good, 2, and then, uh-oh, nope, this is different. Oh, handles 1. Okay, so far so good. 8, 2, 1, 6. Now we're in the fixed portion. 6, 0, 5, 0. 6, 0. 6, 0, 5. 605? 605. It's totally different. Oh man. Okay. So what is the 0B that we sent before? Or sorry, the FB that we sent before? Because this one, I think this one was totally accurate as to what we should be sending at that point in time. I don't think that changes from send to send when we send connection parameters. Oh boy. We gotta double check that. There might be a nuance to this that I didn't have. So I would need to have another EVT connection parameters fixed. I need to look to see whether or not the register is equal to something. Because it's not just a matter of having sent it before at this point, because it sends it multiple times. I'd have to look at the overall register to figure out whether or not it's an FFFF. So I can do, just as a way to do this sloppily, right? fixed 1. For I don't want it to. I want it to evaluate the if once. If status. So bit read status 1 of 4 was 4, right? Yeah. Status 1 of 4, and really the way that I should do this is by passing another thing into here, but status 4 is equal to 1, and param, put spaces in there, is equal to 0x fb. We do that, and then I'll just do else, and that'll be that one. Wait, let's get indented. Am I missing a parenthesis for this? Blah, blah, blah. Yeah, I am. No. Okay. Let me add one here. Bop. Output buffer 12 is the parameter, and then send the output buffer. Okay. So for that, we just do parameters fixed 1. That's sloppy, but whatever. Relevant links only, and I'm not doing audio. You should know that. You've been around here long enough. I can't vet out stuff with audio, so I don't even know what you're requesting. I'm just blowing it away because you didn't even ask. All right, parameters fixed 1, parameters fixed, blah, blah, blah. 4, 5, blah, 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 those work. Okay, so now we need to look at the fixed portion of the packet and see what the changes are. So, 2, 1, 6, 0, 5, 0. So 5, 0. 5, 0, C8. Geez, it's hard to compare these with the windows flopping on top of one another. C8, 0, 0, 1B. Oh no, that gets replaced. Yeah, FB 0. This part I just replace out of order. It doesn't matter. I'll make it FB, whatever. It still gets replaced by the FB that I'm passing into the function. What's up, Turts? Yeah, so that replaces it with a totally different packet when this has already been set and this function's been called, and the parameter is equal to FB. That might not still work. Damn it! Hold on, and status 1 is equal to 0xFFFF. Jesus Christ. That means I can get rid of this. Because I don't know where the FB is invoked. I don't know where that's invoked. It might be invoked at a point. It might be invoked after the first time this status has been set. So it has to be like this. Otherwise, I need to add a special register for it, which is the next step. What's up? Not much. I'm trying to get over this stuff. I'm trying to get this stuff to configure properly. We're at a point of finding hidden serial messages that come in at random times that have completely different packet structures from the other ones like it. And I need to make sure that I'm responding to these correctly, or else it unregisters the module. I thought this would be a lot easier than this. This is getting a little crazy. So yeah, I've just gotta look at the status register and say if it's full, then we'll do the whole thing. Oh man. All right. So anyway, that's still 9. Everything is still good. We go through it and then we replace it with a parameter, even though we don't need to. So if the parameter is equal to FB, which is it's the byte that I'm passing into the function, that should then add to, well, when this event is triggered, it should then set everything in motion. Let's go back. Let's compare. Let's take a look at what we get again. Although now, I think now that we've updated that, we should probably roll through the code. But let's zoom out a little bit here, and let's see what the next stuff that comes in is. This would be the normal timing expiration. Normal timing expiration. Nothing new. Normal timing expiration. Normal timing. Okay, so I think it's in regular operation mode. So that may be the end of it. If we're lucky. That may be the end of it. Guys, that was a lot to go through. Thank you for sticking with me through that. I know my viewers is like they're just hemorrhaging right now. Just because this is not exciting stuff. This is just like the work that it takes to get something like this running. But I think we're getting there. I think we're getting there. I'm gonna upload this to the TNC 3.0. So I hit applaud. And I don't think there are many flaws with my logic, but there may be a couple missing semicolons. There are not missing semicolons in my logic, which is rare. Let's see if we can see some stuff going on here. So open the serial monitor. It says serial started. Did I spell that wrong? Let me turn on the module. You can watch it come up to fruition here. Beep, bop, bop, bobbity, beep, bop, bop. Oops, we're not auto-scrolling. All the way up until this happens. Let's unclick scroll, and let me just take a capture of all this crap. And then we can analyze it at human speed. Before doing that, let me just check. Oh, I closed the Granite Devices stuff. Hold on. Project, stream, Mercwheel, and then software, and then this is over here. Simucube, conf tool. I'm liking what I see. I'm liking what I see. Connection 100%. That's looking, oh! We did it. It works. Oh, son of a bitch. Oh, I can stretch. I can relax. Let's get the serial prints out of there, but it looks like it works. We've got a button press going on, finally. We did it. Chat, we fucking did it. It's a little slow in pressing the buttons, but that was the whole point of the tester. I'm gonna drown myself in my fancy water. Oh my god. That was a pain in my ass. I am no longer acknowledging 69 bits. Find a new joke, fat and ah, damn it, he found a new joke almost immediately. Thank you for the $4.20. Sorry, $4.20. You fuck. No, wait, they're not 10 cents. Thank you for the... Is that 40? That's 42 cents. No, wait. Each one is 1 cent, right? So yeah, it's 42 cents. Penny a bit. Penny farthing. Each one is a penny, which means you knock it over 2 decimal points. So yeah, $4.20. Thank you for the nearly 50 cents and then the $4.20. I appreciate it, but I have to do it begrudgingly because it's fucking funny sex number. funny weed, funny number joke. All right. Look at that. That has been 4 weeks in the making, being able to do this. Gifted you almost a gallon of gas. Not for long, if OPEC gets their way. Stop it. Just stop. Stop being a weird person. Weird pervert. Stop it. All right. I can make the activity feed look like that. That's hard to... My default updated. Oh, every time I move... Ah! What is this new thing? Look, every time I move something, it's like... Stop it. Stop with the pop-ups. Ah! Stop it. Ah, it's popping. We're popping off. All right. I'm just trying to make that a little, like, less... I can't make it less into the window. Sheets did a $3.99 weekend. You know, this is like with insulin prices, where they're like, under, you know, 7 different stipulations, we'll make insulin prices affordable for like, let's have an affordable insulin price weekend. It's like, wait, you could have done this the whole time then? They got billions of dollars in like profit increases. It's such bullshit. Oh my god. Like every other civilized country has a windfall tax. Anyway, look at that. We're pushing buttons. Chat's pushing my buttons, which only goes so far, especially when I'm in the height of stress, which was 3 minutes ago. Buttons are being pushed consistently. The device is up. It looks like, I mean, hell, I don't know if what we did was the right thing, but it looks like what we did was the right thing. So, now we get to go into my other code, and we need to throw it into this code. So this code is now going to expand, perpetually expanding code. But what we need to do is we need to make this code read stuff from the LIN bus. And once it does that, then we will be able to press buttons with complete alacrity on our final system. That little flashing circle is all I needed to see for everything to work properly now. Oh, Lord. Fucking hell. This is what I've been getting, like, trying to get at for months. Well, month. Has it been months? I can't even tell anymore. I'm happy that the rest of this stuff worked out properly, but man alive, that was a lot of fucking bullshit that I had to go through in order to get here. Well, home stretch. Home stretch. In order to get it working on the other device, I'm going to have to solder in 2 lines that'll go to TX, RX, and not ground. It's already connected to ground. And then I'm going to have to deactivate the parts of the LIN bus stuff that is connected to that. But let's... we're still in the trenches, I guess. Let's get rid of a lot of the parts of our code that we don't need. And then we should be able to move code into this code and get it working properly. I'm going to turn everything off. Got a little bit of work to do here. We will start with getting the serial printouts that we don't need out of here. So first of all, in the printer, I have... Now I'm going to keep a lot of these serial prints. I worked hard to get these things to look right. Worked hard for this. What kind of serial printouts are you talking about? Breakfast cereal. I finally just got this fucking thing to work. If you just got here. So huge amount of relief. We can stop working on this stuff. It's the sniffer that really led us to it, because we were able to find, for instance, this signal right here, which is a sneaky update on the connection parameters. That actually, well, it's actually, I think, over here. All the way over here where we start to see normal operation, all of a sudden it says, hey, set some connection parameters. And we get some unique connection parameters all the way out here. And if it doesn't get that, it disconnects the device. So this right here, this signal right here, this little thing that's hanging off, this little chad hanging off at the end of everything, this is what we discovered suddenly made everything else work. Yeah, the $15 logic analyzer and your insistence upon my getting it and using it definitely saved the day. Yeah, I've been saying I needed to get one for years. It was finally just Twisted Sister being like, you should get a logic analyzer. And I'm like, you know, that might actually be a good idea at this point. Because being able to see all these signals in regards to time meant that one of our things was not receiving properly. Like it wasn't getting. There were signals that would be transmitted that were directly on top of themselves, and we weren't able to print those out in my little Arduino serial printer. I had to reconfigure a couple things in order to get that working. That was one of the problems. The next problem is looking at the module coming up to working with time as one of the axes. That was the really important one. And what that allowed me to do is compare how signals are responded to how we're responding to signals. We're still responding to signals in a weird way, right? We're not necessarily responding to them exactly the way it thinks that it does here. We respond a lot faster, which is fine, because the module actually has work to do in between these signals. But what we're able to also do is find out that at the very end, we get another request for signal parameters, but this time they mean war. No, this time we actually get a different response. So now I have this event connection parameters fixed to number 1, and this one has slightly different data in it. 6000032 blah 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 becomes 6005 C8, and then of course FB. We sent an FB that looks like this earlier, but now that everything is up and configured, we send this one. And that solved it. That got it working. There's a couple things that I need to get out of this program now, including on our packet sender. That's not here. This is the receive engine. This is the transmit engine. Transmit engine contains all of the packet building functions, as well as the events that I can trigger and add to the event buffer. And nothing else. Yeah. Specifically just to organize it. Oopsie daisy. It's in the functions that we have the send function. And in the send function, that's a 2-line function, we can just get rid of the packet buffer. That'll clean up our prints. Is there anything else we're printing that we shouldn't? I don't think so. No, I'm not going to add any jitter to it. I could add jitter to it to make it realistic, but the program doesn't care. We saw for at least like a minute or two that it stayed connected, so I'm pretty happy with how that is. I'm going to be adding a tab to this. Name new file. F. Lin stuff. In addition to that, in the timing functions, let's see. Button presser, completely obsolete. We don't need this. Button presser's gone. Let's see. In the functions, when we check readiness and we add, if status is equal to F, ready1 is equal to 1, what's starting off our button presser? By the way, I didn't use typing in order to create the modules and their statuses and their events and stuff. I should have done that. Yeah, this has been it's been a slog, and I think a lot of the beating my head against the wall is just part of the process. Let's be honest, chat. When you're doing something like this, you're running off of a limited set of information. So from where we are right now, it looks like the best way to do this would have been to throw everything in the toilet and flush it until it's gone. No, the best way to go about doing this would have been to start with an example from SI Labs. And I tried to do that when we discovered finally that it was an SI Labs device. But nobody's really coming at it from our perspective, right? So the process of getting to where we are, I don't think there's a lot we could have done to alter it. You have to give yourself credit for functioning within the limits that you exist. Whatever. Anyway, hold on. I'm looking to see this. By the way, this broke the program, so that's not a good event. That's not a good thing. I tried to have it stop timers, but I don't know. Now I'm looking for where we start the button timer. So maybe it's where we do the receive. Yeah, here we go. 11. Button presser. Bop. That's dead. Command 11, we could have it set off a register that we're looking for, and then that will enable LIN bus scanning. And we'll see if that breaks our program. So we can add, it probably should be specific to the module, though. I mean, I could double up with the ready one, because it's not like we're using that. Bool button 1, 0. That means that I need to redo it when status is equal to 0, though. Like if the module resets, it needs to stop looking at buttons. I know. I can go over here. Twisted Sister, thank you for the gift sub to Tim19862, making a nice even number on that massive gift sub number. Yeah, this is the tighten up. This is the tighten up the bolts and then make the prototype, put the body panels on the prototype, right? So I need to look at where we determine this is there. If it's not, and ready 1 is equal to 0, ready 1 is equal to 1. That's not where I'm resetting it. If status does not equal all Fs and ready 1 is equal to 1, ready 1 is equal to 0, buttons of 1 is equal to 0. That's where it resets. Gifting a sub. Wait, 6 months? I didn't notice that. Dude, 6 months of subs to Male Bixie and Males Bixie and Twisted Sister giving Tim19862 6 months. You guys will be like in a totally different situation. You'll be like, wait, my bother sub has expired. What the hell? Dude, congrats, you two. Thank you so much, Twisted Sister. I appreciate the very, very generous gift subs. He's wailing it up out here, man. Oh, button 1. Buttons 1. Whatever. So buttons 1 will just get set and unset depending on whether or not all these status registers are ready to go. If all these status registers are ready to go, you know, erroneous button presses at the wrong time won't tank the system. It hasn't necessarily set up buttons yet, but we can put that in there, and then when we set 11 in the RX engine, we'll just set buttons of 1 is equal to 1, and that's where it'll get set, because these are the set registers. 9-5 set characteristic notification 11 buttons 1 is equal to 1. So now in our main loop, oops, that's over here, setup loop, pop. Here we can do if buttons. I love using variables like this, booleans, and you can just put them in the parentheses, so it seems like a little bit more like an idiot programmed it. It's just like, if buttons, do the thing. So this is where we're going to put our functions now that we're going to add into this thing. All right, chat. Lin stuff. File, open. Oh boy. So this is where we have a bunch of stuff going on. Where are we? Desktop. Stream projects. Stream. There's grandma. Stream projects. Where you go? Stream. Mercwheel. Those are some very generous gift subs. Thank you very much. I Really appreciate that a lot. Mercwheel, Arduino, Linduino Master, Linduino M. Here we go. Here's another 5 billion line piece of code that we put into this thing. Ah! 433. Still a lot. Now I could just cut paste this whole thing into here. And it would just simply, I think it would just work. All our timing info and stuff is in here. And then our loop is just that. Just as long as none of my variables... Oh boy. Well, we also have a different setup and loop, so... Time set, time out, wheel size, wheel 9, shift, pedal. Let's, all right, so we're gonna add this to our setup. So Lin Arduino, Lin Master. I hope this is the latest one. Let me just double check. Because the, hold on. 5/8/2020. Oops. 5/8/2020 versus 4/26/2020. So yeah, I guess it's the latest. I hope it works. These are just the logic analyzer recordings. Okay, all right. I say no task scheduling, but I do have task scheduling. I could always add scanning Lin to a list of events now. Actually, do we need to stop the event timer? No, because we're still using events to trigger the RSSI and battery updates. Yeah, see, these are a bunch of, like, pins. Where's Uncle Phil? He'll get pissed off at me using Addy again. All right, so let's take, first of all, let's take all of my wonderful text. And I'm just going to put that in as a block. Not here. Now I'm going to have to rename engine test, so... But again, this just, I mean, the way things are organized, whatever. So below our EVT stack, we're going to do... Oops, not enough. Not enough. Actually, new tab. This one will be... I'm going to have to rename all the tabs, though, if I do this. I want this tab to be up there next to the other one, because then I can have Bluetooth engine, and I should probably have a tab that's all just the write-up, and then I can have all of the settings for Lin bus, and then I can all the settings for... All right, let's not add too many tabs. It gets... Tabs are addictive. You'll get addicted to them. Lin bus settings. I mean, it would be helpful. It'll help me, like, space stuff out, you know? Oops. All right, so let's get all our settings in here. And it looks like for once none of my stuff is gonna collide. All my variable names and stuff. Seen so many. At a bus stop. Half naked, still drunk from the night before. Hey, man, got any tabs? And you're like, I think you've had enough, man. You have one variable on this tab. Oh, but there's a lot of text. And you're like, you shake your head and you walk away. He used to be a wonderful developer. All right, so anyway, that's all our pin settings and stuff. Usually I like the physical stuff to be first, but since this program is the way that it is, yeah, but it'll keep it organized. Yeah, like your life is organized, buddy. That's different. How dare you say that to me? I don't care to learn how LinBus works again. I could learn. I've got it on the tip of my tongue, but man, this stuff, the bit ordering and flipping and stuff like that is an absolute nightmare. The stuff with the port expander, we don't necessarily need. How come we're not setting up any libraries in this program? May need I2C port expander? Wait a minute. This isn't the code. This is the code. Son of a bitch. Yeah, this is the code. All right. Well, luckily we nipped that one in the bud. I need to put my folders in different places. That's annoying. All right, so let's take our write up. This is why you put a date on all of your headers. Proceeds to not put a date on the header. So what's going on here? E-brake, E46, no CRC yet. Shifter buttons 2. 8 shifter button pins. Yeah, so here's the one that was rewritten for the 8 shifter. So at least we know what's going on. Okay. I'm gonna stand up a little bit here. So I think for the most part, this thing is putting all the right stuff in all the right places, except we need to somehow extract from either the variables or whatever. We need to get those button responses. The analogs will speak to their own thing. So then we go bop bop, and we put... I'm going to keep the MPC 23017. I'm going to keep the port expander just in case. But we're going to set all of its pins to be low, and we'll keep it there. Wire.h is in there so that we... Well, actually, wire.h is for the port expander. MPC 23017, I believe, is the analog potentiometer. Sorry, the digital potentiometer. Yeah, whatever. Okay, that's the header. Next, I need to get rid of all this stuff. Bonk. Okay, so now I need it from the other one. I need addresses. I need this stuff. Yeah, we're just going to take this whole thing. All the way down to setup. And things like time between LinBus asks, well, actually, I believe if we run our function once, we run our LinBus loop once, I think it'll ask once, maybe. I need to figure that out. We need to maybe rewrite a couple things. We're adding microsecond timing to this thing. It's going to be a beast. So setup. Setup. Tesh buttons we don't need anymore. Tab. Doot. Lin. Bus. And then up here, this would be BT engine. Okay, cool. LIN bus, Bluetooth engine. Grab all this stuff. Oh, we're not going to need the serial stuff. I'll get rid of that soon. Jeez, there's a lot of garbage in this. Copy and paste. So Digipot is the potentiometer. We're going to need that. MCP write registers, so that's 0xFF, 0xFF, GPIO A and B. MPC port mode, A and B. MPC init. Analog indicators, no. TC actual pinouts, no. Diagnostic, no. Digital write, blah, blah, blah. This thing we get rid of. SDA, SCL for the wire mode, the LIN pins, TX and RX, input and output. We will need to make sure that they don't collide with the other pins that we're using. Currently, we're using those two. Yeah, they collide. We're going to have to move our serial port to another port, huh? LIN is using serial 2. We're already using serial 2. Or no, we're not even using serial 2. We're using just 2 pins that are right there. Damn it! Yeah, we're going to have to figure out how we can move our entire TX and RX engine over from serial 2. But that'll be a hardware thing in a minute. I believe... Here, hold on. Let's pull up a Teensy 3.2 pinout. Oh, that's like the super duper one. No. Huh. Well, because right now the pins that we're using for LIN bus are... Hold on, let me pull them up on the software. Why is it asking me this? What the f... Why did that close? Well, we saved it anyway. Wouldn't it have been funny if we had lost all that work? All right, what pins are we using? Wheel address, MPC address. What? 18 and 19? What? Really? We're using those pins? That's like on the other side. Okay. 18 and 19, but then we're looking for the output. 10 and 11. So that's 10 and 11 right here. TX2 and RX2. We might need to do our output on TX3 and RX3, which is easy enough for us to change. Or I can move pin 10 over to pin 12. Where's my note? Oh, it's in the setup. I should probably... Let me make a physical note of that. That's probably going to stick a little bit better with me if I actually write it down. So pin... What is it? Pin... Let me pull up the pins in front of me again. Just to make sure. I got a lot of work to do. I mean, we can probably get this done by tomorrow, and then be ready for Saturday to do a little My Summer Car, which is pretty ambitious. But I mean, I've got the proof of concept for both systems. So TX RX LIN TX 10 RX 11 10 to 12. So 9 and 10 can be serial 2. Okay, that way we don't have to alter the code we spent so much time on. No, that's just what's connected. That's we're not using them like normal serial buses or serial pins rather. 10 and 11 are what. That's what I'm literally looking at the what's connected right now. Those are because we're bit banging it. So instead, why not bit bang 11 and 12? Those can do the same functions. I'll just move pin 10 over. I'll make a little jump, and then I'll have 9 and 10 that I can just run to an external connector, and that'll be fine. I don't know why I did it that way. Probably messed up something, or it just worked out that way on the perf board. All we need to do is shift this stuff into our button packets. That's fun. That'll be easy to do. We can just for loop that shit. Yeah. Those are bytes. The UN8s rather. Wait, there's 9 of these. Which one does that do then? We got it working. We just need to put LIN bus stuff in it. E-brake I haven't implemented yet. That's going to be an analog. Pedals I think are already all worked out. I think we need to invert one of them. Lights I'm not doing yet, etc., etc. I think there's some functions in there with the sizes. I don't know why I'm taking the exact sizes. I should have subtracted one here. Okay, so we got all that stuff in there. We've got our setup. We got rid of the serial print in the setup. We've got all of our MCP write registers and digital pots and stuff like that. Those are on different pins. Those are totally fine. I mean, if we write, we don't have to write to those constantly because those will only write. We do have to write to those constantly. That's true. In our loop, this is our main loop here. Over here, we need to look at wheel delay, shift delay, pedals delay, shift 8 delay. All right, that's easy. Button outs, pot outs. So we want to always read from the pedals and output. Now the question is whether or not we want to, well, we can wait to read from everybody. Oh my God. My doctor sent an updated prescription to CVS, and so it's taken liberty to inform me, even though we all know that I can't get the prescription yet. It's like, there's all kinds of problems with the prescription. It's like the opposite problem that I had earlier. All right. How do I want to do this? How do I want to organize this? Because, I mean, when everything works, we'll want to do the wheel and the shifter. Not that shifter. I guess, okay, so let me bring all the functions in. All of you come with me. And then we'll go into here, if buttons. And then I have all this stuff. And in this case, we don't need this. And let's reformat these. We don't need these. I don't have them yet. So we do the wheel, delay, pedals, delay, shift. We don't need a delay there because we go and do other stuff. And this might take a very small amount of time to get back to. So maybe I do need to just put a little delay in the end there. I don't know how much of a delay I actually need on these. I may not need the delay function at all. I don't know. Let me just organize this a little bit more. Okay. So 8-speed shifter pedals in the wheel, all with little delays in them. I mean, that I could pack into a singular function, but whatever. And that's going to give us all of our data, and it's only if the button register is active and everybody's ready to go. So the potentiometers are going to be in an initial state. I think that's okay. Yeah, that's perfectly fine. So we do all that stuff if the buttons register is active. So once that gets active, then we do all the other stuff. Oh wait, no. I keep looking through tabs as if I'm going to find it there. We are in this program. So what I'm doing is I'm opening up the two programs on top of one another, and I'm looking to see what functions I need to move over to the other. And if I had programmed everything correctly, which is not necessarily the case, then I would actually be able to do all this stuff properly. I'd be able to move all this stuff over cleanly. Button outs is going to change, but that'll do like changing the buttons, and then the button check is going to catch that. So when the loop goes down and it gets the data, and then I can have it put the data into the thing with this function, put the data into the potentiometers, do the serial prints if we're doing diagnostic, and then come back around and do all this other stuff. Come back around, and then when it gets to the button scan, I think should happen after this function, just so it's instant. Just in case, I don't know, people are sensitive to delays. So we'll do the button scan after that, and I'll get rid of the comments below. That way, we scan to see if any of the button registers have changed, and if they have, we send it out on the serial line. Wah! Stretch! So yeah, that whole function just makes sure that we're not doing this stuff if, here, let's just put like a... Lin functions. Okay, so now we have Lin's stuff, and we're just gonna bust all this stuff into there, I guess. Looks like we're ready to go. Let's fucking go. The only thing I have to do is alter the hardware, but let's get the software together first, because it sucks. Because it sucks. Because it sucks and nobody wants to do it. Functions. Down we go, all the way down to the end of the program. This is just all the stuff that I've programmed in order to handle Lin bus. And if you like this stuff, if you like sitting here and watching me tear my hair out over microsecond timings, boy, you would have loved the Lin bus stuff that we did. This all works, but man, it was a beast to get together. This is mostly bit banging. It sucks. And it sucks. Okay. So, now that we've put all this stuff together, we need to take a look at these registers, or rather these variables. I know we broke a lot of tiny 85s. We had to make both ends of the system, though. We need to look at all of this stuff, and what we need to do is we need to move the data from here into our button registers. So this would be, really it should go into the timing functions, but that's silly. We need to move that data into buttons 1. Move 1, well, 4, 8, 12, 16, 20, 24, 28 times 2, 48 buttons, right? My math is impeccable. Don't worry about it. I think it's actually 8, 16, 24, 32, 40, 48. There we go. I don't know what these initial buttons are. I don't know if we're editing them or not, or if they're available to us for some reason. I don't know. I don't know what they are. But either way, we'll be moving the data into these portions of the of that 32T as ones and zeros. It's kind of a shame I didn't put them into a 32T to begin with, and I'm not editing that. I could probably make what was I thinking? Anyway, I could probably make this thing work on stuff a little bit more clearly. Like, you know, I could make it move the bits in better. Because I mean, it is just receiving them as bytes. I think I'm just throwing bytes into bytes, aren't I? Oh Lord, we got to remind ourselves how this data is going in. So our function for putting stuff in there is, and I quote, button outs. So instead of button outs, we got to look for button outs. So we got to find that here. And there it is. Button outs. Packet A, packet B. Camera 1, camera 2. Oh, Lord. All this weird interaction needs maybe to be handled a little bit differently, doesn't it? All this weird interaction that we got the microcontroller doing here. We got this microcontroller doing a lot of work, don't we? The analog outs we can keep. They just work in exactly the same way. We don't need to worry about that. And we figured out the ranges that it was getting, and hopefully those are still calibrated properly, but so we don't need to MCP write registers anymore. Ta-da! Unless we really need it. That would be packet A and packet B. We don't need that anymore. And we are reading bits individually, so wheel of position. So this gets a lot simpler. I almost don't care where we're doing, where we're doing all this stuff. I want to keep a record of this because I want to be able to do this the same way. But I don't think I really need to worry about any of this interaction. Now, GoNad has sung the praise. TurboNad, if you guys are willing to follow his channel, has sung the praise of having an actual button. I think Groovy also talked about this, having a button assigned to neutral. I'm not going to assign a button to neutral. From what I know of my summer car, it doesn't care. It doesn't care. I think what we can just do is just shift things in. We can make either a couple loops, or I can just do it directly. I can just do wheel of 2 of 2 is button 1 of something of something. So all of this stuff, button outs, I'm going to take this, I'm going to put it into a dead function. I'm going to make it a void. Void port expander outs. So button outs. What are we doing? So we are doing, we're loading everything into bit sets, right? Do I want to use bit sets or we don't want to use bit set and bit clear in this instance. So we have a wheel of, so it's wheel and what's the other one? Shift of. The other one's Shift 8, so it's Shift 8 of, and then it's wheel of. So do we, I could do a billion if-elses, or we could go, probably bit by bit is probably the best way to do it. I think we do a couple for loops. For int I, let's do the wheel first and then the shifter. This is going to be so simple because all it's going to do is just throw bit for bit, you know, thing into thing. I don't know. Is the wheel that compact? What does the wheel have? No, the wheel has a bunch of different. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, blank, 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 14, 15, 16, 17, blank, 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 blank. And then Shift 8 is just I don't really need to know what they are specifically because I'm just going to push them and things will happen. I pushed a button and things happen. Yeah. Let's get these things and just put them in here just so we know. Just so we know. So we have that data. Oh, there's a blank one. Dun, dun, dun. How is there a blank one? 0, 1, 2, 3, 4, 5, 6, 7. I guess so. 1, 2, 3, 4, 5, 6, 7, 8. Well, there's 2. Oh, it's an entire blank. Okay, so there's an entire blank at the end of it. Just in case I want like a button on the shifter or something, have like an analog on the shifter where if I really kick it into first gear, like, it'll actually do something. It'll do like an analog. Oh, thank you for the shout out. Sorry, Fadanon. I just noticed that you were. That was almost really rude. I'm sorry. I was almost like, were you talking? No. Thank you for shouting him out. So we're gonna do for loops, and we're just gonna throw it into the registers. So our wheel is weird. The wheel wah wah. The wheel is weird. Yeah, I guess we're doing a bit read. Wheel of blank of blank. Should we do it one at a time? You got other pretty things that I got you around for. No, I'm not going to say that. I shouldn't say that. Wheel of something of something. Wheel of 0, I guess. We're just going to have to go through it one by one. Wheel of 0, I. But if it's only 1, 2, 3, 4... Well, this one's for the whole thing. Do we really need to have that in, like, for loops? That's so weird. Actually, wait a minute. I can do... I could, like, mask it and do weird shifts on it. That would be one way to do it. Mask and shift and do all kinds of weird shit. Weird programmer horny shit to it. No, that's not a good idea. I don't know. I'll confuse myself if I do that. I'll hurt myself in my anger. So we want... button 1... I mean, God, I could do this with binary functions, or I could actually, like, just do it like bit set is not the way to do that. If bit read of wheel of I, then bit button 1 set, but then I need to unset it if it's not. That's such a weird function to put in there. All right, let's do it that way. Let's just do it that way. For int I is equal to 0. No, that's so stupid, though. Button 1 is equal to wheel of 0 shifted 8. Well, shifted 32. How many do I have to shift it to get it there? Where do I have the timing stuff? The timing stuff I dealt with 32s. That's just why I want to reference it. Where's my timer setting function? Oh, that's in timing functions. Duh. 8, 16, 24. So let's set it 24. Is that 24? If I shift it over 24, 24, 25, 26, 27. And that, yeah, that makes up, but it's 48. Oh my God, my brain hurts. Hello, it's me, brain. But then I need like these blank sections in there. I thought we filled up all the registers with this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. 3 more that we're missing? Hold on, let me check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. That's like 23 buttons. Close enough. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I think I missed one. 16, 17, 18, 19, 20, 21, 22, 23. Yeah, okay. All right. So it is 23 buttons. So we have 23 positions that we can occupy. I mean, I could just make a giant function and it would just be super simple, but yeah, I hurt myself in my own confusion. It's just like I suddenly just slammed my head down on the desk. The problem is this is so comparatively simple to what we were doing before. I could either iterate through this or I could use methods of shifting. So I could take wheel of 1, shift it over 1, and then I could put it in to a certain location, but then I always I second guess my shifts. So if I take this and I put it in the remainder, and then I take this and I put it in the remainder, like what does that leave us with? How far over should I need to shift it? Or I could just put like 1, 2, 3, 4. Well, it's 3 that I need it to fit in. So that would shift over 1. This one would take up, oh yeah, see there's that 0 in there that I really don't like. Ah, fuck it. Let's just do it this way. So wheel of 0. Well, if our initial code works, then we'll move on from there. But button 1, wheel of 0, shift 24. It's actually shifted. Yeah, shifted 24. Well, do I want it to be the LSB or the MSB? Because if I want it to be the MSB, I could just put it in there as nothing. Is equal to wheel of 0. Then button 1 or equals wheel of 1 shifted. Is that gonna work? Or do I need to shift it first and then shift it again? I don't know. These are indeed the faster way to do this. It doesn't need to be fast, but yeah, I don't want to do it that way. I just want to reference the locations, so. But if I do bit sets and clears, then I got to use loops. Can I reference a uint32t as a location? 24t? What are they? What are they? Yeah, it's a uint32. And I don't want to wipe that F0 at the beginning, so I think maybe I need to bit set and bit clear. Ah! Okay. I don't want to do that, though. Hold on a minute. But I need to overwrite. I need to take over the bits. I can't just XOR them. So I need to bit mask and then do something. But that's silly. That's the smarter way to do it, and that's the way that people would normally do it. So the dumb way to do it is the way that I would do it, which is the way I am going to do it. All right, we'll just do loops. I is equal to 0. I plus plus. Oops. I is less than or equal to. Which direction should we go? Let's go LSB to MSB. That way I can just start my numbers and count them up as we go, right? Because the numbers are going to get larger and larger and more confusing. If I could just manually set... Oh, I need 2 pictures and then draw arrows between them. Because otherwise, I mean, this goes in directly. We're not doing this one. This goes in directly. This one shifts over 1. These shift over 1, and then they go in here. Yeah, it's easier just to do it this way. All right, so for int I is equal to 0, I is less than or equal to, what are we doing? Six? Wait. Oh, 7. What the hell is my counting? What's up with my counting? So 0 to 7. I'm just going to do this with very simple loops because my brain doesn't work right. So, if bit read of, no, yeah, wheel 1, sorry, wheel 0, I. We'll just iterate through this way. And then that's going to be an else. And then bit set. And then that's going to be buttons or buttons of 1. And then the location is also I, because it's 0 to 7. We're going to start at the beginning. So that would be wheel, sorry, a bit clear for the bottom one, bit clear. And the other one's bit set. I'm sorry to do it this way. I know everybody's cringing. Bit set. So from 0 to 7, wheel of 0 of I, ba ba ba. So we're just going to step through that. For that, do that. Take it again. This time we're going to do just these 4, just these 4. So for that, we are then going to continue 0 for int I is equal to and wheel of 1. And then we're going to do I starts at 1. 1, 2, 3, 4. 4. Read wheel of 1, position 1, and that's going to equal buttons of 1, position I plus, and that starts at 1, and then that 1 is going to have to equal 8, so we put 7 in there. That's where we left off. But this starts at 1, so it's offset by 1. We're not back on this stuff again. This is new. And then bit clear I plus 7. So that'll clear those. Now, actually, which is the MSB here? Which is the LSB? Because this whole thing's going to get flipped on its head when it goes back into the packet. But it gets a little endianed. I think starting at 0 starts at the MSB, which is all the way to the right. I think. Let's check. Arduino reference. Blah, 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 bit set, bit clear. 0, numeric value, starting at 0 for the least significant rightmost bit. Yeah. Wait, least significant? That's the leftmost bit. No, I guess that's the rightmost bit. Is that really the case? Least significant is the right... Man, I always get that mixed up. I think we're doing it right. It all looks the same. Well, it's Arduino programming. I mean, we're all going to be doing a certain degree of what looks like this. So yeah, I think we're good. I think we're good to keep going like this. I hope I don't have to flip it over because that's going to break my brain. We're just taking it for each block. So wheel 0. This is more complicated than I think it probably needs to be. It's just I don't want to break my mind trying to do all the little complicated shiftings in here, because I could have another variable and have it like put everything together the way it should, but it doesn't matter. Wheel 2. It's 0, 1, 2. Yeah, 0, 1, 2, and then shift of 1 or of 0. Well, or just shift 8, but we'll give it a 0. Because actually shift 8 is a 0 and a 1. We just don't use the 1. So we got this one. Now we're on a weird one. We have blah blank blah blah. Yeah, the teensy runs so fast. I hope we don't introduce any issue. I'm gonna hit save right now, but just in case. We can get rid of the for loop on this one. And we keep the if else. And we just give it a number. Hell, I could even just pack them in like that, but I'll put the else on another line just to be kind. Bit read, wheel. Did I just mess up the code that I Control Z, Control Z, Control Z, Control Z, Control Z, Control Z, put it all back together. Repeat. There you go. Let's not mesh that up. Rid of the if statement. Rid of dish. Take the brackets, put them up here. Take this, compact it, because it's just one function that runs. For that, do that, else do this. For int I, wait a minute, if. Oops, messed that up. Meshed it up. So if that, do that. Okay, so bit set, bit clear. And then I need a couple of these, but let me just, this would be wheel of 2. Wheel 2 of 0. Buttons 1 of and then it's no longer 0. So it's going to be, it's then equal to 4, 7, 11. So this one would be 12. We'll double check that. Thirteen, 13, 13, 13, 13, 13, 13. I screwed up. 12, 13, 13, 14, 14, 15, 15? That should be way further along than, that should be like 24. What is going on? Hold on, we'll take, this is gonna take a little bit of checking over. 16, 17, 18, 19, 20, 21, 2, never mind, that is where it should be. That is where it should be. A little space in there. Yeah, this is sloppy. This is Sunodere simulator levels of coding that I'm doing right now. The bit operations are the way that it should go. Whatever. So wheel of 2, position 0, position 2, position 3, 0, 2, 3, and then that's it. 0, 2, 3. I don't need this last one. Well, something's missing. I'm probably missing something. We'll check it over. We'll check it over. We'll find this when we check it over. 0, skip 1, 2, and 3. 0, skip 1, 2, and 3. And then those are not used. So if that's set our button position, or otherwise clear the button position. All right, so for the shift 8 is basically going to be the same thing as this first line right here for the wheel. 0 to 7, only it's going to be the next positions. If that for loop, if loop, else loop, I'm beeping, hold on. Whoa! Huge shift in glucose level. Oh, I'm doing pretty good though. All right, yeah, cool. Cool. So, what are the numbers here? This would be I plus 14. No, I plus 15. I plus 15 because it starts at 0. All right, double checking. 15 plus 7, 16, 17, 18, 19, 20, 22. Doesn't make any sense. We're gonna have to check this over and make sure that we've got the right numbers on this thing. So what's gonna happen when we run this? Well, a whole lot of bullshit. A whole lot of stuff that could have been probably resolved a little bit easier with, if I could keep my binary shifting, stable in my mind, but I can't. So we're gonna start with the wheel buttons. So wheel of 0, because wheel's an array. I didn't use like a big number. Wheel of 0, I. Wheel of 0, I starts at 0. So we start at 0, we go until we equal 7, and then we break the loop. We read the bit. Well, oh my God, stop beeping at me, you fucking asshole. God, just beeped at me. It beeped at me once, then it beeps immediately after. It stresses me the fuck out. All right, anyway, wheel buttons first 3 bytes. So we go 0, 1, 2, 3, 4, 5, 6, 7, and we shift it into, oh, not shifted it, we should shift it into, but we bit set it into buttons of 1. So if this is true, and are these inverted or not? I forget. I think these are 1 if they are checksum of blah. I don't know. Okay, anyway. All that code works, so I'm not going to mess with it. I don't know whether they're 1s or 0s in order to be active or not. I don't think it goes low to be active. If it does, we're going to have a little bit of inverting to do. But okay. So we go 0, 1, 2, 3, 4, 5, 6, 7 in wheel of 0, and we do button 1 of 0 through 7. So we're at position 7. Position 7 has been set. So we need to now do these. So we go to int is equal to, I is equal to 1, and we go for 4. So 1, 2, 3, 4. We're at position 7 that we've already programmed. So I is equal to 1. Oops. So wheel of 1, which is this. We start at 1 here, talk. Talk goes into 1 plus 7, which is 8. So position 8. And then we go until I is less than or equal to 4. So 1, 2, 3, 4. It should be 3. Well, it's 4 positions, but it's 1, 2, 3. That doesn't make any sense. Hold on. I is equal to, maybe we need to offset it differently. But it's not, 0 is, we're not using 1, 2, 3, 4. And then 5 is outright. 1, 2, 3, 4, 7, 8, 9, 10, 11. So we just programmed position 11 in, no. Yes. 7, 8, 9, 10. Okay. 7, 8, 9, 10, 11, though. Wait a minute. Something's totally wrong. I think we need... No, we don't need a less than or equal to. We're programming 4 buttons. We're starting at 1, but it's I plus 7. Something's wrong with my loop. Hold on a minute. We start at 1, so that would be position 8, because we just programmed position 7. So 8, 9, 10, 11 is where we should end up. So 8, 9, 10, 11, 7 plus 4. And then we end at 4, which is position 5 of this thing. So that's correct. So we just programmed 11. So now we go into this mess, just because there's a blank in the middle of this thing, and I don't want to deal with the ramifications of that. So, and there's only 2 buttons after that. So, we just programmed 11. So now we look at wheel of 2. So 0, 1, 2 of 0. And that is programmed into position 12. Hold on, don't try to follow along. Then we go to 2. So 0, 1, 2, and 3, and 3. 2 and 3, 12, 13, 14. Okay. Now we need to put all of this in. We don't care about the blank byte. We want these 8 bits. These 8 bits go in from the H shifter. It doesn't matter what their exact identities are. So the next 8 bits, 0 to 7, they're plus 15 because the last thing we programmed was 14. So 0 plus 15 is 15. Wheel of, not 0. Blah, blah, blah. Oh, this would be shift 8 of 0. Shift 8 of 0. If the bit is a 1, we set buttons 1 at that position. If it's a 1, we set it at the position. If it's a 0, we clear it, and we're done. Okay, double checked. Save. All right, we got to do a little hardware, and then we can test this whole program out. Because when buttons 1 gets written after the end of this, stuff will have changed, and then it'll be able to press the button on the main controller. Man, we're not used to doing hardware around here, huh? I've been doing programming for so long. I'm going to have to take a break. I'm going to take a little break before we do hardware on this thing, because we need to desolder the 1 pin. I need to move it over. Let me program that before I forget to. So what we do is we'll just take pin 10 and we'll jump it over to pin 11, or 12 rather. Boop. There it is. Yeah, we do hardware occasionally. You fucking asshole. That's it. Man, that's wild. Okay. So having almost programmed everything correctly, we were able to have this comprehensive giant program in this whole thing. If I wanted to add another button press thing, that would be very difficult to do. There'd be a lot of work to do in that. I'd have to change over the way that the Bluetooth fake out thing handles the modules, basically. It would need to treat the modules as a type, which means they would get registered and have all these default values go into them, and that could then lead to having all the settings and stuff in there. We get this working today. It's kind of wild, right? First one writes bit 0 to 7. The second one writes bit 8 to 11. Yeah, so it's just because of the way the packet comes in. The way the packet comes in, there's like blank spots in there, and they're probably for different models of car. Probably different Mercedeses have different button layouts. They might have different button functions in a different part of the packet. Hey, stomach, can I just say something, like one sentence without you fucking me up? Yeah, so it probably for different models of car, it has different stuff that happens in there. But since we have the particular steering wheel we have, our packets are all spaced out and weird. Now, technically, we could shift these, and you know, I could shift that over and do 0 to whatever. This one is a little bit more difficult, but maybe I could like shift that over 1. So wheel of 0 is equal to wheel of 0, shift it over with position, shifted it. Oh God, it would look bit mask or something like that. I didn't want to get into that. It's all very complicated. All right, I will BRB. I'm gonna lock my computer so you guys can't get into it. No, I'm just gonna put on the background music that I had before, and I'll be back in just a second. Where the hell is my window? There it is. Look, it's Julian's hands. Overlays, BRB. Yeah, that'll be good. All right, BRB. Getting real sick of this part. In the middle of my face. I feel like I'm wearing a wig. I don't think I can do the haircut tomorrow though, because I gotta do storage space stuff in the morning. If I'm late tomorrow, it means that people who are out of my control have really absolutely shitty scheduling abilities. So truly bad scheduling abilities. Okay, let's we gotta power through this. Well, I mean, there's not. We're not at a boring part. We're at a fun part. But we got to power through the rest of this project because we potentially get this to the point of hardware being done where I could just move it over to the, it won't be 100% done, but it'll be done enough that we can play a game with it, which means I can move it over to the other desk and we can do a game stream. I might be able to get to there today because we got a couple hours left. We're good on time. I'm really excited about that. If this works, which it should work, this can be a major thing. So I'm gonna rearrange my windows here out of programming mode, and we'll go back into regular mode. So I can save this program. I hope we get to there, but we'll see. And I can close the Linbus stuff because we've gotten everything we've needed out of this thing, even the programs that I didn't finish programming. And we can get rid of Linduino main, which is the actual Wait a minute. Did I get the end of the program out of it? Hold on. That would be a funny. Ha 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 ha. Open recent. Although it starts in this tiny little window. I just need to check something real quick. I need to make sure that the remainder of the Linbus stuff that we got was out of the right one. I think we did. So Linduino main ends with diagnostic. Yoink. Leading zeros. Oh yeah, I have a function in here. Prints binary with leading zeros. I should have known about printf. That would have been good to know. Instead, I have a loop that does that. Okay, I think we got the right stuff. Yeah, serial prints, all that stuff. Go back up to the main loop. That one's the one with all the delays in it. Yep, there we go. Wheel. It's funny, I probably could do all the shifting when we actually get the addresses and have it just punch it into the thing. That's all right. We'll have functions on top of functions. Optimization is for another time. Okay, so we need to turn the Linbus pin from pin 10 to pin 12. So it needs to just skip over the other pin. So we'll just do a little skip over and then go to the microcontroller pin. And then we need to get the 2 pins from that, and we need to move it over to probably a wire. I'll just do 2 jumpers. They're already sharing ground, so they already know the voltage levels each other's speaking. Oops, sorry. I have to scroll to get to all of my stuff now. Hold on, I need to get rid of this one. That one needs to go. I was kind of working on like a Fusion 360 view, but I never really got it to work right, so there we go. That's better. Oh, yeah, that window's over there. Okay, all right. Let's do a little hardware. I gotta do a little cleanup before I do a little hardware. I need to make room for myself to exist, and I need to get the O-scope out of the way. This will be a troubleshooting tool. And our test setup out of the way. Although I do need to be cognizant of which pin is TX and which pin is RX. I don't want to get that wrong the first time. Let's figure out which one is TX and RX, huh? Granite Devices pin out. I need to open up on the other screen. So let's pull that window over there. Let me do Granite Devices. Ione-Cube. I opened up the wrong one. There we go. Simucube pin out. I'm just going to look to see which one is TX and RX, and that is an image that I need to pull up there. That's this thing right here. So we're looking at header 4 serial. They call it the serial display connector because if they don't get a what do you call it? Whoa, what's the camera doing? If they don't get a Scilab's Bluetooth device connected, it will start sending out packets that look a lot like probably what look like serial display things. It looks for the Bluetooth module, but then it moves over and it does a display. I'm wondering if there's a way to get it to do just the button presses right away. There probably is, but I have absolutely no idea what that packet would look like. There's probably a special thing that this thing can receive, and it's probably pretty easy to program if they would just give us that information. But without that information, I'm shit out of luck. So anyway, we had to do all that work over the past couple weeks to get this entire system up and running. So, all right. Pinout 4. Ground, 3 volts, ground, TX-RX. So 3 and 2. Now, the one at the very bottom of the header is 5 volts. So the one next to that is RX. That's the orange wire, that's the yellow wire. And the yellow wire goes to the orange wire again. And then that wire goes to that one. This is like those SAT tests or whatever, the function test. That one goes to pin 9. So RX pin 9, which would be TX on this one. No, RX pin 9. Okay. All right, so we follow this convention. RX pin 9. I'm going to double check that. RX pin 9, first pin, this one. Over there, one on the end, orange. Orange goes to yellow, goes to yellow, goes to orange, goes to the bottom pin next to the single pin is RxD1. Okay, good. So it's RX to RX. What's up, Chester? We're almost done. Maybe. Well, we're almost modified to the point where we can try the full software because I got the test working. There's a hidden status packet that we didn't respond properly to. Whew. Okay. So we need to, yeah, I got the buttons to press. I got it to press and I got it depressed. I mean, I got it to press a button and then unpress a button. That's pretty cool. So that's pretty cool. I was pretty excited about that. Actually, I wasn't. I don't show any emotion. I don't have enough dopamine in my brain to show emotion. All right. Let us put this thing over here. Clean up a little bit. I mean, I'm going to have to take that connection away. I guess we're not going to need to sniff it, huh? Dun, dun, dun. Bonk. So it's RX to RX, TX to TX. Just got to remember that. And we don't need 120 volts going into the thing right now. That's a liability. And we don't need the motor connected. We don't need the encoder connected. And we don't need USB. Not at the moment. Grab the whole thing, bring it over here. I would love to move this out of my way, but I guess I probably need it to be here. This will be sort of an in situ modification. I could pull this entire board and work on it, or we could just work on it sitting right here. I guess sitting right here would be the way to go. I need to get into these two right here. So that's pin 10 and 11, and that's what connects us to the LIN bus. Let's get my controls back over here so that I can change the focus. I can rack focus. There we go. So if you guys haven't seen this before, this is the circuit board that we created in order to initially control all of the stuff in the Simucube. This is a laser power supply box from a friend of mine in Philadelphia. Their cutting laser died, and he's like, you want some cool stuff? Maybe you could use it as an art project. And I'm like, all right. So I took a look, and the only really useful stuff out of it was the power supplies for the lasers. They ended up being useful in that they have kind of neat little cases that promote airflow from one end to the other. So I crammed a bunch of wires in here. We used a radio connector for the motor, which is a nice big 3-pin connector, and technically you could use the outer ground as the 4th pin. So this is a wonderful motor control, like a 3-phase motor connector. It's actually beautiful. It's DB15 size, so you can just cut a hole. Man, I really wish DB connector punches should be more common because they're awesome. DB connector punches are great. You drill 2 holes and then you just tighten them up and they pop out your DB connector sized hole. But anyway, DB connector size hole, 3-phase motor. You can put a, you know, the ground, the middle of the wire, the whatever. I think this is a Delta. I forget what it's wired up as. DB15 for all of the encoder signals, A, B, Z, as well as I think a couple other things, but also the LIN bus. The LIN bus is part of that whole thing. It's actually only like 2 of the pins. I think the encoder uses 5 volts. So yeah, it would be LIN bus is 3 of these pins. So the LIN bus goes all the way out to that box over there. I cut a hole in it and I put a little 3-pin JST connector on it. So we have a little JST connector distributor block over there, and we're able to get LIN bus from all the accessories all the way into this box with a nice elegant plug. This will eventually be for an emergency stop, but I've not had an emergency with this thing yet. So, you know, maybe after I have my hand chopped off by it. All these plugs over here are from the port expander and from the 2 analog, the 2 digital potentiometers. These are kind of hard to get in there, but we were able to get it eventually. We've got digital potentiometers connected to 3 of the analog inputs in here, so that come the event when I actually put together my e-brake and figure out how I'm going to do that. Of course, TurboNAD keeps telling me to just put it on like a stool next to you. I'm like, I will then throw the stool across the room if that's the case. Like, that's not going to work out for me. That needs to be locked down if I'm going to have a parking brake. Although TurboNAD's been using his parking brake for helicopter simulators, so that sounds awesome. I got to see that next time I get a chance. So yeah, I haven't figured that one out yet. This is the Granite Devices Simucube controller. It's got a little stand-up card in it, and that stand-up card has to be directly in airflow. Well, in addition to that, we also have a 48-volt, 48-amp. How many amps is this thing? 10 amp. 10 amps at 48 volts coming out of this thing. This is a big power supply. It's a big, expensive power supply. I put tape on it so that it wouldn't reflect into the camera and, like, blow out my eyes. And an Noctua fan, because why not? Little 90mm fan. What that's doing is it's blowing through the power supply, and anything left over hits the motor controller. That's been good for cooling. Nothing has gotten hot in here. There are 2 USB connectors on the outside of this thing. One of them is to configure the motor. The other one is to configure the rest of the thing and to get those readouts that we were looking at before. Up here, we have our port expander, which is, of course, wired up to the Ethernet cable. There are additional pins on the port expander. All of them are being used, and they're going into the stock pins here. These are still available to us. We haven't used any of them in our current system. Hopefully, these all go to a zeroed state when everything starts up. So we're pretty much maxing out the inputs, but we're not necessarily using any of these. In the future, for like the lighting controller and stuff like that, I can put that on here. So that'll be interesting. Over here, Arduino, Teensy 3.2. It's a beast. This thing is amazing. Couple things over here that are kind of interesting. The first one was the only device that Pololu sold that was able to take up to 50 volts in and turn it into, I think 12 volts. I think this is 48 to 12, and then this is 12 to 5. So the 5 volts are powering, ow, I have a pimple on my nose. I have like a fledgling pimple on my nose, and I just scratched my nose and caught it. My nose is going to be bright red tomorrow, isn't it? Well, if we can do a game stream tomorrow, maybe I don't have to be on camera. Actually, I do, because I want to show off the system. Damn it. I never get a win. We'll do like a buttoning up the system later. We need to make sure it works first. I forget which ones it is. It's probably 48 to 12, and then this one is 12 to 5. 5 volts goes to the Arduino, and then 12 volts goes to the other side of this. Because what this does, this is the LIN bus. I forget what company makes it. It's a LIN bus transceiver. You get a TX and an RX. You get the 1-wire LIN bus exiting this, and then this will make your device voltage for you if you want it to. We don't. We're not using that. But if we wanted to, we could power 5 volts over here from the LIN bus. This is a really good chip. It's pretty cheap, and you can put it in a bunch of different places. Like if you put it in your device, it'll power your device with its little internal voltage regulator, and then you send it your ones and your zeros, and LIN bus will come out the other end. It's weird that I wasn't able to find more LIN bus for the Arduino, though. It's weird that I wasn't able to find anything. But we created the LIN bus with bit banging techniques, because you need to hold the line low for a certain amount of time to get your LIN bus accessories to respond. Man, you know, here we are. Okay, so we need to do a little bit of modification to the pinouts of this thing, and so I made this removable, as you should. You should make these things removable. Be kind to yourself, chat. We just carefully work that thing out. The hovercrafts are all over the place today. So we need to connect this header up here, not permanently. I can make a header here just using a little bit of wire. Probably the best way to do it. I can make it facing downwards like we did before. It'll be just a little 2-pin header that'll do TX and RX. Maybe I can make it over here. This is kind of in the way. This is another like connection thing. What connects over there? Fan power external potentiometers. Oh, I think that's if I want to have like a force feedback potentiometer, which I kind of do. Connection 2. They're just additional potentiometers, huh? Yeah, looks like it. So if I wanted to have more analog inputs, I guess I could put them in there. The connectors on this thing are weird. I think they assume that like people would, I don't even know, like put this with their pedals, I guess, and then you could, I guess, direct wire it. That's not a bad idea. Really not a bad location for it, because you'd want it. I mean, I think the ideal location for the thing is somewhere in between your pedals and your steering wheel, right? And so if you're doing that, you might as well put the box with your pedals and then run these wires directly so that the two are always one thing, and then you can have the Ethernet cables between your other stuff, and then the motor and the controller here connecting with the, because this isn't a great plug to have like plugged and unplugged all the time. And there's an emergency stop with it. Like it's really, I don't know, the ins and outs on this board are confusing to me. Maybe it's just what was cheap. It was cheap at the time. It was like power inputs over here. Anyway, okay. So yeah, let's do that. Let's get this all wired up. I'm gonna get my wires out, which are wire wrap wires. They're 30 gauge, so they're very small. They're for small signal stuff. I don't really put any significant amounts of power through it. They're not for a microcontroller. They're solid, and you can lay them down on perforated prototyping board and relatively keep out of your own way. I got to turn off all my motion detectors. Man, chat is just like flying by today. I can't keep up. Disarmed. Okay. So let's get to work. So this line right here, we need to move to here. The way I'm going to do that is I'm just going to jump straight over it. Actually, I should go under. I'm going to go under with a solid line. Let me check to see if anything's running by that location. Yeah, we're going to go under. I'm going to go under with a solid wire. The advantage to using this type of perforated prototyping board, in addition to it being one-sided so that I can run bare wire underneath it, these are square pads, and those square pads are really nice for surface mount devices. So yeah, we can just rip that to here, and then I can put it under and put it up there and to this last pin, pin 12. Alrighty. Oh, we can actually get thermal imaging back on the stream so that people can come in here and rudely ask me, why would you have a thermal cam? It's like, the fuck, why not? Why wouldn't I have a thermal cam? What's wrong with you? Give me that thermal. Yeah. Like, what's wrong with people? Like, why are they so rude? Is it just because it's like a chat on the internet means that you can just be awful to people? Especially when they're like giving a presentation in front of a bunch of people, you know? It just always, it always gets me. I don't know. Maybe I'm just easy to get. I'm an easy mark. Always have been. Don't tolerate that shit in your lives, chat. Just don't do it. All right, I guess what I'm going to do is I'm going to pull back a little bit of the solder on this thing. We can do a multi-microscope view. Let's do that. That would be the wrong one. Why is that? Why are we looking at the surface of the sun right now? Why is this like this? Wait a minute. Let's set up the micro. Hold on. Did you not? Did you not? Yeah, you didn't get brought through the procedure. Oh my God, maybe you did. Are you like this? That's a little better. All right, so here we are, Chad. Look at us. Look at us go. Wait, this is supposed to be a multi-view. Oh no, here we go. There we go. Back to brass tacks. Probably like move chat in this view, but the problem is I need my microscope view. I have an idea. I have an idea where you guys can go. Do you guys need your own color source or can I import it? I'll just copy it from another scene. That was the wrong scene. That was the wrong, this is the wrong scene too. I never use this one. Let's copy it from... I thought I gave you guys a box the other day. Oh yeah, you do have a box. Okay. Copy, and then we'll go to this one, and then I'm gonna paste it as a paste duplicate. There we go. Put that all the way down here. And then instead of moving you guys up to the corner, put you guys, that's gonna block a lot of that, isn't it? You guys like right in the middle. It's gonna block everything though. It's gonna block more of my view. I mean, I can stick you guys up in the corner. Never stick chat in the corner. How dare you? I mean, you can sit here and potshot little fucking comments about my soldering, but I don't see you streaming, so. Also, this technique was taught to me by some of the best soldering people that I've ever met. All right, so got our two lines coming in here, and I need to pull back the wire on the one. That's always a tough maneuver. Plus, this is a prototype, and if you're gonna hold yourself to the standards of professional electronics all the time, you will never make any prototypes. Circuit boards are cheap to make. I'm not willing to make a circuit board for this project. Well, I know I've put a lot into coding it, and it, you know, it would look really nice with a professional circuit board, but that takes time and effort, and I've already put enough time and effort into this thing. Go fuck yourself. All right, let's see. I don't want to jump over directly. I'll do it here. Do it right here. But I also need to pull this out of here because I need to well, no, I don't need to pull it out of there. I can just desolder it there. So I can use a little bit of metal fatigue on this. This technique looks very sloppy on a microscope, but it's a good technique. It works very well. I made a lot of circuit boards with this. Nowadays, of course, you could just have a circuit board made. But, you know, who's got $5? I don't got $5. Nobody got $5. Look at the cost of gas. I wonder what delivery prices are gonna, like, what's gonna happen to cheap circuit board prices with all the inflation and stuff. I mean, Fusion's already changing their pricing. Oh, thank you for the 500 binims. I still don't have $5 though. I'm not making a circuit board for this thing if that's what you're trying to push. I know you're just trying to make me look stupid. Like you always do. Okay, let's do that, and then I'm gonna jump it underneath and go to pin 12. I'm going to use a regular wire and just strip the coating off of it because I'm running out of the unjacketed stuff. Yeah, well, when you get it overseas, there's some places that I need to check out that are in America. I mean, I guess if you're not in America, it's it gets real tough. But if you're not in America, I don't know what to say. But if you're in the States and you want to get a circuit board, there are some places that do it cheaply. I hope I don't hit the card. The card is like directly underneath this. The card's like hopefully here. Actually, it's right here. So we might just be out of the way. Yeah, if you're in the States, it's possible that you could go and get a circuit board. I really got to see what the hell's making all that noise. If it's that 1 gigabyte hard drive that I've got in here, I'm concerned for its health. That's a lot of like hard drive writing noise that I'm listening to right now out of this computer. That's like a rattle. It sounds like an old hard drive writing. How do you check the smart status on a drive? Engravers just don't make. I don't think they make very good PCBs. They're not very clean, and the services are so cheap. The only time I think you'd really need like an engraver is if you make tons of them. ZCPU? I don't know if I have that. I don't think that. I mean, I just got the 6 terabyte drive, right? It could, I don't know if it's the FreeNAS making the noise or if it's FreeNAS. I would get a warning if any of the smarts are depreciated, and I looked at that. They're all good. I think maybe this is the Stream PC with the 6 terabyte drive just going a little haywire. And it might just be working normally, and I could just hear it more for some reason. I just ate a hoagie. Why am I hungry? My body's like, hey, bro, you're hungry now. It's like, no, I'm not. Like, God damn it, I am not. There's no reality in which I should be hungry right now. Yeah, it's definitely normal. It's like loud hard drive writing noises. Ow, that was hot. Ow. I need to use tweezers for that. First time you hear the word matrix? High school. And that was around 1999, but it was a little bit earlier. But everybody was starting to go psycho about The Matrix, and they overhyped it for me, so I never saw it in theaters. Never saw it in theaters. Even though it made, like, influenced the whole generation. Yeah, AP Math was like the main reason people knew the term. Is that cold welded? It might be cold soldered in. I can't see under the pin, and I already melted it too much. Shit, I bungled that. I bungled it! There it is. It's gonna unseat the pin header, and then I'm not gonna be able to plug it back in. There we go. See, now I can wiggle it without the other one moving. Metal fatigue, metal fatigue, metal fatigue, metal fatigue, metal fatigue, metal fatigue, metal fatigue. Oh, come on. What the? Oh my God. It's spring steel. Oh, no, it's not. Clean the plastic off of the iron. The World of the Matrix? I don't know about that, man. That last movie was I don't know what to make of that last movie. Oh, I see. Yeah. Well, in that case, yeah. Oh my God. The cell phones have LCDs on them. It's the promised land. I mean, it's the early 2000s. Plug me in. Max Payne just came out? Oh. There's a Matrix mod. Oh man, I can't speak for the Twitch app. I don't know. All right, so now we freed up our pins. We've got our pins that are for TX and RX right here. So we're probably gonna go this way to whatever blank spot we can afford. I would say over here, but it's kind of a distance to go. Whereas I could do them up and over and just connect them to the pin headers right there. I think that's the way I should do it. Because there's nothing under there, so I'll be able to reach them. All right, so 2-pin header, and then I need a 2-pin socket in order to put the header on. That's not a great view. We'll just do that one. There we go. All right, 2-pin header, 2-pin socket. This pin. 2 and 2. So probably a normal pin header, and then I can just chop up a DuPont connector. Or I can just find a DuPont connector. Just because they gamify things doesn't mean that we live in a game. Don't get that twisted. You keep that straight. Don't let them win when it comes to gamifying stuff. Yeah, my credit score, I got a min-max. I fucking, you know, before the 80s, nobody had a credit score. For the late 80s, right? I gotta get solder ready at the same time. Die Hard Harry Potter. What? Well, they're all that same type of story. You know, the hero's ascension. All of those subreddits that exist now dedicated to like Harry Potter fans, where it's called like read another book. Because they become so obsessed with Harry Potter that they relate it to every facet of life. Like, please, just pick up another book. This is like when Voldemort... No, stop it, please. All right, 2-pin header. I actually should keep that. Fico, 1999? 1989, sorry. Huh. I was alive. I was alive before credit was a thing. To be alive before credit scores are a thing, huh? Is it like crooked? The header's probably all kinds of jacked up. That's okay though. So we need 2 wires. I'll just do like a little multicolor thing. We'll go blue and white. Usually a good way to go. Blue and white. Give them a little distance. They don't need much. They don't need much. They don't got a long way to go. And then clip them. All right, so TX and RX pins. What pins are they? These are pins 10 and 9. Pins 10 and 9. Ten und 9. So what can I do for those? I could do down and up and over, or I should probably do down and then just route them over to where they need to go. So they'll just pop up right here at pin 10 and 9, and then they'll go to where they need to go. So what I'll do is I'll strip off a little bit of them over here. Give them a little right angle at the end. And those will slot in. Is it HW info that's giving me a lot of hard drive activity? I don't think it should be. Where are we? Intel, EVGA, EVGA, EVGA. 50 degrees in there. Smart. No, nothing smart going on. Absolutely no smart going on here. Remaining life, 97. 97. Well, that thing just has to survive until I fill it. But there's no failures or anything. It's just slightly lower. We use 10% of our brain. If we used 100% of our brain, we would have seizures. So we would be just a seizure. We would just be everything twitching. What is this? Read activity, write activity. 6 on Western Digital. The 5600, which one is that? 500 gigabytes. That's the SSD. So this one is probably the 6 terabyte one. There's no activity on it, but I just keep hearing that, you know, hard drive working noise coming out of it. But the smart statuses are okay with everything. 97% drive life is not amazing, but that drive just needs to survive until I fill it up, which is not going to be all that long from now. Okay, it is going to be a little bit long from now. All right. Right. Well, YouTube is different. YouTube is put the drive into a caddy and then edit the video out of that. So these two go into these two. My hope is that we don't have to do a whole lot of tinkering in order to get this thing up and running. 2 megabyte files. Oh, because I have YouTube open? But it shouldn't be using that drive. The other drive's an SSD. If it's making noise, we have other problems. Oh, hold on. All the way down to the bottom. I made these a little too long. That's all right. I'm working with the board in the thing, so it's a little bit more difficult to maneuver. No, the storage drive is a storage drive. I don't know if that was clear from what I was talking about before. Chat. Well, actually, something I specifically know. I just wanted to sound smart. Okay. Well, I have to wrangle that into position, but let's assume the position. That a little bit like that. The problem is, as I solder these, I have to pinch them with the tweezers, and in doing so, I will melt the wire. Maybe I probably could have soldered them and then positioned the wire in the appropriate spot. That probably would have been the better way to do it. Because then I could have routed the wire through. I always forget my techniques. You got organic mercury. I vaguely remember that. I don't have much recollection of past experiences. Because you get weird stuff like that. Oh, are you talking about specific physics thing? No? No, I never was. Yeah, there's actually a list of well, that's for Tasmota. Tasmota has a list of devices that you can flash. And that doesn't mean, you know, it doesn't necessarily mean it won't have a have an ESP in it, but it oftentimes means that it does. Shame though that it doesn't. It's gonna damage the pin header, isn't it? Ugh. I don't like it. I forget what we were talking about when that came up, but it was like so specific. It was so specific. It was just like, why? Why would you bring that up? Nobody was talking about that. Brillenshuker. Hey, there's an old name. Brillenshuker with 29 months. How's your Brillen? Is it still sugared? Good to see you. I like seeing the old names. Means you guys are still alive. You can't tell anymore sometimes. Okay, since I can't see what I'm doing, I need to make sure that they actually made a connection and that my soldering isn't absolutely abhorrent. Yeah, like that. That would have been an issue. Doing this kind of header soldering is always kind of an issue. It's a little difficult to do. There are some things my technique kind of lacks in. Shit. Fuck. Shit, fuck. Come on. Ugh. These are things that are easier for me to fix without you guys watching. And probably if I had just laid the wire down with it on top of the board, soldered it, and then routed it through, it probably would have turned out a lot better. Oh well, try again. Yeah, see, that always distresses the jacket around it. I want a little bit of the jacket up here so that I can see which wire is carrying which signal. Nice, you got tomorrow off. Wait, what is... Oh, 4th of July. Yeah, not really feeling all that patriotic this year, huh? not really feeling it this year, this little 4th of July thing. Then again, my past couple 4th of Julys, I haven't been doing much. I mean, geez, last year we were all hunkered down. What's up, Krillin? Okay, so I need to go to these two pins, and I need to make sure that it's clear which one is which one. I want to make the bottom one RX. RX is the bottom pin here, too, if I recall correctly, which we need to recall correctly. So let's see here. Nope, TX. So we want the top one, the white wire, to be RX. So we want the white wire to the bottom one. Wreckfest of the boys. I do need to do a Wreckfest, but not with you shouty people. No, I don't know. I don't know. If anything, the promise is that I do my summer car. So I need the white wire to be at the bottom. Let's do our sewing homework. You guys will never be able to suggest a game for me to play. Predator View. Why do people call it that? Predator didn't invent thermals. They just bought some shitty 80s one. I I don't know whose color palette that was anyway, but you can tell when stuff is the Lepton color palette. That GIF went around, that GIF went around recently that was 4 cats sitting on a bed and one farts and all the cats look over, right? Well, the cats look over at the one that farted, right? And you're like, haha, funny fart cat. Here's the deal. The camera for that little GIF was exactly the same color palette as the one that you're looking at right now. It is a Lepton color palette. It's this combination of purple and yellow representing the heat of an area. Now, this sensor doesn't have multiple color palettes. However, it can have other color palettes. The data is sent in as data. It's not sent in as color, right? It actually is a black and white image when it's received. That image then gets applied to, you know, whatever color mask you want. And you can have multiple different ones. So when you look at that GIF of the 4 cats sitting there, and one of them farts, the fart coming out of the cat is from white to green to black to like some other color. The yellow was in there. And you're like, ha, funny stinky fart, because you have one brain cell and it happened to hit the corner of your head. You people are dumb. Or at least the people upvoting that thing are dumb. I'm having trouble finding this whole. Anyway, people are fucking dumb. So they think haha funny thermal cam showed the fart. But I'll tell you right now, if I fart in front of my thermal cam, something I will never do, you won't be able to see it. You might see the pants changing color after a little bit. But the thing is, your fart is leaving your body temperature, and your pants, on the inside at least, are body temperature. And the amount of the air that gets out of it is not going to be really that visible. Maybe if you were like Andre the Giant, and you can let out a 45-second fart on set, maybe something would be detectable in thermals. But that GIF shows a different color palette for the fart. So basically they took a GIF that they took with a thermal imager. They said, oh, cool, thermal imager. I wonder what the cats look like under it. Oh, wow, that's a really nice little thing that I've gotten, that I've captured here. And it shows, I need to do this from the other side, hold on. And it shows all 4 of the cats sitting there, and they all look at this one, at Mr. Tiggles, or whatever the hell, you know, the cat's name is. I'm gonna go with Mr. Tiggles, though. They all look at the one cat, and so they photoshopped in, or, you know, whatever, Premiere Pro'd in that fart, that gas expulsion in a different thermal imager. And if you look closely, it doesn't even track the movement of the camera properly. They fucked it up that bad, is that it does not even track the movement of the camera. If you look at the cat's butt and where the fart cloud starts, it wiggles disproportionately and has like a different distance to the cat. So it is a very amateurish editing job. You gotta be aware of that stuff, chat. You gotta be able to deal with that stuff in life and on the internet. It's an important skill to have. Always be suspicious of things. In addition to that, there's the one with the firefighters that are playing with the thermal imager, and he farts, and it's haha funny fart. Once again, but you can't see a fart like that on a thermal imager. They had a fire extinguisher that they used in order to make that plume of smoke come out from behind the person. Because it dissipates in your pants, believe it or not. It's just a lot of fart GIFs that circulate. Oh, geez, that's totally uneven. It just pisses me off as somebody who has access to thermal imaging. Everybody goes, haha, funny. Haha, poopy. Uh-oh, stinky. And then you have to be like, guys, like, this is not what you think it is. Oh my god, I laugh so funny when the fart. Now, the most striking thing you can do with thermal imaging is take a piss. That's where the fun begins. That's like loading a glow stick into a super soaker. That's the thing people need to capture, but they never do. They never do. They never capture pissing with a thermal imager. Now, this will send a lot of good TX and RX data, what we just soldered. This will be great. Check it out. Yeah. Look at all that TX and RX data that we're going to send out of that thing. Because we're not allowed to have fun on this channel, all right? I've specifically requested that it be prohibited, so I don't know why anybody is having fun. Okay. TX and RX. Now we just need to find a wire. That's a little sloppy, but I think I'm willing to just keep it that way. All right. TX and RX. Let's see what we can drum up here. I need a DuPont to DuPont, and I need it to not be 1,000,000 miles long, because otherwise we'll introduce a nice little loop where a bunch of noise can get into our system. Now, yeah, fart jokes are still funny. I'm doing a bit, chat. Doing a bit. All right. DuPont to DuPont. Like, man, what is up with this streamer? He hates fart jokes, but he built a device that makes fart noises and laughs at it. What a hypocrite that person is. What a hypocrite. I'm not gonna stand for this. This is ridiculous. I've pointed it out to him many times. These are all the same length, aren't they? Yeah. I had shorter ones. Oh well. All right. So, wow, this is a really shitty connection, huh? This is not that good. Whatever, it's fine. It's fine. I can redo it later if I want to, which means never. It'll never get redone. Ever, ever, ever. Never, ever, ever. It'll always be like this, unless I build a board in Fusion that sits on top of this thing and takes up a lot less space. I could make something like that big, but look at how long this is. Holy crap. Well, if this doesn't work, maybe cable length is to blame. Just like stuff it over there. So green wire down, bottom 2 of this one. And that, my friends, should get it all working. So for next stream, no, just kidding. we'll test this before we're done here today. Of course we'll test this. This is where forceps are a good tool in the shop. Forceps are wonderful. They're finglongers. Before the finglonger was invented, we had forceps. Let's make sure that I'm plugging it into the right one, too. 34. So RX is the blue wire. No, it's the white wire. White wire is on the bottom. White wire to green wire to RX. Which is header. Actually, that's header 5. Oh, yeah, because that's flipped around. So green to RX, I need to flip them over. Plug them in with tweezers. Yeah, at this point, I could probably make a circuit board that has all this stuff on it, huh? Wouldn't be that hard to do. I wouldn't directly install the, just to save myself all the trouble. There is Paul Stoffrigan on his website, pjrc.com, has a standalone version of the chip that's already like ready to go. So you can buy that and then use it directly on the board, but I don't want to do that. I could just put headers down and then use one of his. This is a project that absolutely probably needs a teensy. You could, but meh. Oh, you know. What do you mean? Of the one teensy? Do you want to sit here and do all the serial conversions that it's doing? Or do you wish that you had invented it? Because it is a wonderful piece of equipment. It is a wonderful piece of equipment. It is a very extremely brutally fast microcontroller that will, if you have a project of any sort of middling complexity, it'll handle it without even breaking a sweat. Speaking of breaking a sweat, do we want predictions? Is Fat still hanging out? We could start a does it work prediction. I'm going to double check my TX and RX. So TX is blue, it's the bottom pin. Blue bottom pin, I'm going to look at the card with the pin out. TX2, pin 10. TX2, pin 10. Blue wire. Blue wire goes to the top one over here, which goes to the blue wire, which goes to the bottom one over here that's right next to the blank spot. Over here, the blank spot on header number 5 is NC, and it's pin 6. TX and RX are up here. Pin 1 is all the way at the top. No, pin 1's all the way at the bottom. That's how we had it connected before anyway. Yeah, pin 1 is marked, it's all the way at the bottom. So all the way at the top, we have, they label these upside down. So TX is RX, RX is TX. The wires are a little bit long, but oh boy, here we go. So what we're looking for is for, here, wait, we're looking for this program to be able to show button presses. This project is entirely complicated. I'm gonna let the predictions. Do I have to let that bar end before people? Yeah, I have to let that bar end. So we have a moment. So I can double check the system and I'll plug everything in and then I'll wait for that to be done, so that people can get their predictions in before I actually power it up. It's a long timer on that. Nobody's around because we've done programming for the past month and everybody ran. Everyone ran away. I fully, hey, I support it. I'm with you. I'm with the runners. Get the hell out of here. This programming sucks. But we might be done it. If this thing works right now, we're done programming. And we'll start another programming project. No, I mean, we'll start a different thing. We'll do something else. We'll play games tomorrow, possibly. Might just do My Summer Car tomorrow and the day after. We might do 2 days of My Summer Car because this thing sucked. And I wanted to get it done. I want to get back to designing my PC shell. I have the rack mount PC shell. I'm going to electrocute myself when I plug this thing in. I'm going to have like my fingers like sweeping the power pins. Oopsies. Make sure that's turned off. That was apparently turned on when I plugged it in. Well, I turned it off immediately. Who's giving you points? What is that symbol by your name? It's all sparkly. Oh, it's a yes prediction. They changed the look of it. Oh. You guys have international restrictions on gambling. Haha, you guys have a nanny state. Our government would never tell us what to do with our bodies. You guys are told you can't gamble. What is it like to have such an oppressive regime tell you that you're not allowed to do something just because someone else opposes it, even though it doesn't affect them at all? What is it like to give voice to people like that who just seem to have the meanest intentions? All right. Bop. What's it like to lose your fucking rights to autonomy? All right. Blah, 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 blah. Plug the thing in. Plug the thing in. Work cert blows up. I don't think the stakes are quite that high. We need to make sure that I program the actual thing, though. That's over here for some reason. The only reason it wouldn't work right now is that I didn't program this. So let's program this. So I need this, the one that I just put away. The one that I just put away. Really? That's cool. Because of the gambling laws, you got to nope out of a sketchy project at work. Living the dream. All right, let's upload to this. I mean, look, I'm all for non-monetary gambling or just shutting the whole fucking thing down. Philly recently got gambling, and so we have the big casino and everything, and all the commercials on TV are now fucking gambling ads. I hate it. Upload. Let's see. There's going to be mistakes in the code, by the way. Yep. Huh? Why? Oh, the NPC likes that. I don't think I'm doing anything with buttons 1. Hold on, let's look to see if I'm doing anything with it. Here, let's go to the programming thing. Buttons 1. Wait, why is there also a bool buttons 1? Button outs, bit set, buttons 1 of I. That's us. We did that. We did that, 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 we did that. Joe Biden did that, we did that, we did that, we did that, we did that. This is us, this is us, this is us. Joe Byron? I would give him a big kiss. Let's see. No, no, no. Buttons 1 is equal to 0. Oh, I just called the variable something stupid. Buttons 1 go or something. That was my fault. I mean, that was Joe Byron. That wasn't me. That was Joe Byron doing that. Where else do we set the wrong buttons register? Nope. Yeah, no, that's now button 1's go. Nope. Yeah, buttons 1 go equal to 1. Okay, I think that might be it. Science streams. I take it you're here for the fellowhood or whatever. Control save. Upload. All right, what's our next mistake? Don't eat a mistake. Ha ha ha, get it? Buttons was not declared of the scope. Oh. Buttons 1 go. Lift off. God damn it. For if ha who's next? I got one over here. All my loop-de-loop stuff. Just a little loopy. Bit read. Yeah, closing functions with double parentheses. Windows bit off screen. Okay, sorry. Hold on. Let me yoink. Let me move the infinite whatever and just put this back. I don't know how it got so wide. Go. They wanted somebody to write a song. Double parenth. double parenth, double, 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 triple with a number 2, double, triple, double, and double, double with cheese. All right, parenths, parenths, parenths. Anybody else? I think that should do it. Let's see what other dumb mistakes we got. We have 2 programs that compiled and worked. We combined them with one function that sort of bridges the 2 together. So, oh my God, we selected the wrong teensy. Tools, board. Teensy Duino, 3.2 or 3.1, and then it thinks about it for a little bit. It's gonna have some little bit of thinking. It's gonna think some stuff. Oh, it's done. Thinking, stinking. Upload. I hope it works. 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 This is the culmination of a lot of stuff. Okay, code is uploaded. We're not even going to look at the serial print. We're just going to look at the functionality of the whole thing. Irregardless of whether it works or not. By the way, when I say stuff like irregardless, I'm actually like saying the wrong word. I'm purposefully doing that. People don't get that sometimes, and they think that that's just like how I talk. It's, you know, I'm putting on a face and I'm saying stupid stuff, and I'm trying to pepper my language with things that people pick up on. Why can't I move you? There it is. All right. I guess we go back to this guy, and I'm gonna move my video window back to where I can actually see it while I'm working. I'm used to having it in one place, so. And then we got the Granite, the Simucube stuff is up. Everybody ready to go? We got our predictions locked in. Wait, there are 3 cases that you can do that? What's the 3rd case? Oh, blows up, yes and no. All right. Guys ready to go? We have one button that seems to be permanently pressed. Ah! The wheel just went psycho. Push a button. Nah, doesn't work. Doesn't work. Let's push a bunch of buttons and see if anything triggers anything. Yeah, we didn't get an earth-shattering kaboom. We're gonna have to look at the serial prints. Nada. Ain't nothing working. Oh, it might be that nothing is plugged in. Hold on, let's check. What's not showing is, oh, the thing, yeah. And I've got like a frame rate problem over here. All right, what's the serial monitor telling us? Board at, oh yeah, I didn't plug it in. Board at USB is not available, huh? Oh boy. All right, so what do we do? It's gonna take a little bit of troubleshooting for us to get to where we need to be with this thing. Are the analogs in a weird spot? Yeah, look at the delay. What is happening? Yeah, we need a readout of what's going on, and I don't have any LED indicators telling me if anything's happening. No smoke is coming out of the unit. Plug in USB. So anybody who said no is correct. It's not even responding to timing. It doesn't even say serial's ready to go. Serial started. I don't know if maybe I need to disable the serial port to get it to run properly. Hold on, I'm going to turn it back on. Do we need like a power on delay? Shouldn't need a power on delay, but maybe it takes a minute to get up. Because there's no serial communications going on right now. Serial started. We're plugged in. We're on serial 2. Our serial's not connected to anything else. We've continuity on the wires, probably. I didn't really check. We've moved LIN bus over to the other pins. obviously 12 volts and stuff is going out on the LIN bus. LIN bus is connected, so that should be okay. And we saw that working earlier. I was able to push buttons and that would work. So if I turn it off, I'll turn it on and hit reset on the Arduino and see if that does it. Turn it on, reset on the Arduino. Serial started. So it's a serial line issue. We're not communicating over the serial line right now. Yeah, okay, so it's a serial issue. A serial issue. So first test is first with the serial line. What we do is we turn it off, unplug our Arduino. Well, I'll keep it plugged in, whatever. Ah, sorry, I punched the camera. We'll just flip the TX and the RX. I'm not looking at chat right now because I don't want their suggestions. So we flip TX and RX because it exists in a superposition. TX and RX is flipped. Everything else is looking good. We didn't do a continuity test. That's going to be the next step. So we have reset the Arduino. Looks like it's being powered kind of independently right now. But if I turn this on, through the serial port, that is. There we go. So it's a TX and RX thing. Which means, oh God, it's spitting out analog values. The serial printout is a mess. Turning, button. Oh, well, oh, that's very slow. Okay, it's a little faster. That's very slow. It hits buttons though. We need to speed it up. That one doesn't even come through. Oh, there it is. Yeah, ooh, it's slow. Some of the buttons aren't coming through. If I like double tap. Oh, there's that one. That may have to do with the LIN bus. The LIN bus may not be quite as stable as it used to be. Shift into a gear. Shit. Hello? Shift into a... Shift into a... It might not be plugged in. Hold on. It's just plugged in. No, it's plugged in. That is indeed plugged in. I might have the old address in here. If we didn't get the right settings. I think we did, though. And we had it working. I remember seeing gears go into it. Well, the wheel works. So if I hit a button on the wheel, that's a shift button. But if I bop, 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 sometimes it's quick, sometimes it's not. We need to figure out how to speed that up. Well, the delay between the LIN bus packets might be at fault here. God, wireless was a lot quicker than this. Yeah, and it's not recognizing some of the buttons too. So one thing I need to do is in the serial printouts, I need to get rid of the analog analog outputs, because they're making the whole thing a psychotic affair. Look at that. Ah! There are button pack. I assure you, there are button packets flowing through there. Oy, oy. All right, I guess we're looking at code again. But this is an amazing amount of progress. The amount of stuff that's happened right now, just to get to where we are right now. Why is that one? It's a one analog is still. Oh, I see, because the analogs are back and forth. Okay. Power down. Oh yeah, this is gonna keep going, isn't it? Good God. That's a mess. It's a mess of serial prints. Oh boy. So why are we still printing out on that thing? Oh, I can't control OBS if OBS isn't on the screen. Oh my God. All right, so LIN bus stuff. Something might be messing up, like maybe this. The ones that weren't working were up okay. This one, talk back, mute. I didn't try the other side. But yeah, it seems like this one is messing up. I don't see why, and it may just be that the way the loops are coming through it's not doing it properly. Or maybe, you know, some kind of a logic in here is not doing it correctly. Let's get rid of the analog prints though. See, this is supposed to be printing this stuff, but print shift, print pedal. It's not even doing this. This isn't actually going on. Print output pots. That crunching noise from the hard drive is very distracting. I don't. It might not be that hard drive. It might be a wire that's brushing a fan. Checksum checker. Micros and seconds. We're looking for where I'm printing out those numbers. Half bit. These are the functions that we're going through. I don't get why that's not returning anything. We're not getting anything back from the shifter. And that should have been simple. Maybe, oh, shift size, shift start. 0 I is less than the shift size. Bit start, shift I is equal to get bits. It might be that we need to instead get, here, wherever we're getting our stuff from. That would be, here's all the mapping. Ah, there's the print. That was what I was looking for. Bop. Cool. That's one problem. Next problem, the shifter is not reporting any values. So we are looking for the, my brain. We are looking for my marbles. Here, shift 8, 8 to 15. And that's still I plus, no. 14, 13, 12, 11, 10, 9, 8, 7. So we're starting at 7. Let's just verify that. We want to start at position 15. So we're starting at position 8. That would be 28. It should be 27. If we start at 7, that means we're position 7 plus 7, which is 14. If we 8, 7 plus, yeah, 8 is 15. 15, and then we go for 8, 16, 17, 18, 19, 20, 21, 22, 23. So 8. Was it plus 8? No. What? My brain hurts. Hold on. 15, 16, 17, 18, 19, 20, 21, 22. We want 23. I want to go to 16. That seems wrong. That seems wrong. But we're trying to shift it into a position 15. 15, 16, 17, 18, 19, 20, 21. 22. That's what we're doing, up to 22, right? So we want 16, 17, 18, 19, 20, 21, 22. That's 6. 16, 17, 18, 19, 20, 21, 22. 6. So it is 15. All right, it is 15. I'm trying to get the counting right because we want the high byte and low byte to go in the right spot. I mean, I guess shift 8, I could use the high byte command and try to clean this up a little bit, but I did it by numerical position, which makes it a little bit more complicated to figure out. But it's a little bit more direct in my mind. But I think maybe bit shifts and stuff like that would probably be easier if I just shuffled everything around. We didn't get anything from the Shift 8, so I'm thinking that we're looking at the wrong bytes. I could have it print out the button packet, but man, it's so hard to figure out what's going on with this thing because there's so many signals running around so quickly. We got some buttons to respond though. So when we come up to function, and everything starts running, we are running this thing. Packet del we need to change though. So let's look at our engine test. We're looking at packet delay, diagnostic, packet del. It's 4 milliseconds. Let's make it 1. That's not a lot of time. I don't know why we're missing so many button presses. I don't know what kind of data we're missing out on, or if maybe we need to tweak some of the like offsets and stuff like that so that it works a little bit more smoothly. Because remember, all this stuff is all timing based. It's all over the place. Half of a bit tweaked. That's one of the tweaking things that we could do. Half of a bit's really supposed to be a little bit, I forget what it's supposed to be. Well, it would be 25 and we set it to 11. But this thing is so fast that I don't know. We got those correct finally. I could have swapped those out. Or no, I would have to swap the other ones. SICLCS are fine. Those are fine. Everything is the same way it was in the hardware. The shift address, I don't know if it's DD or not. Let's open up the old code and see if we retained it. And maybe I've got the wrong number in here. Ooh, wait a minute. Yeah, I might have the wrong settings imported. Ooh. Nope, shame settings. Only that one adds. It's a double equal sign for this new one though. And packet delay is part of that. Wondering if I should just copy this over. But like, I think I did copy it over. No, it's like totally different. Wait a minute. Yeah, where's all my other... it's the wrong file. That may be part of why it's a little funky. I don't know why it would have allowed any of this stuff to be imported, though. I don't even think I got the define in there. Yeah, I didn't even get the define in there. What the hell? All right, yeah, I'm stealing all this stuff. I did copy that, but I didn't copy this. So yeah, you see that? The difference between the two. Oh no, wait, I'm looking at the wrong code. Story of my damn life. Hold on. No, we got the right one. I got the right one. Yeah, that's all the right one. We got all the right stuff. Sorry, never mind. I was looking at the wrong code. Yeah, we got everything in there. So yeah, it's all good. And we just reduced the packet delay to 1. I don't know if that's going to fix it, though, because it seems like it's having a little bit of trouble receiving LIN bus. Like, there are inputs that it's not catching. So maybe it's not happening fast enough. But we don't... So the functions that are running are very light. So over here in the loop, the functions are very light. If we have packet data, then we assess the packet. Otherwise, we check the status of a variable. That can like die almost instantly. Check the status of the module, which is like a millisecond. We check to see whether or not the individual button pressing thing is ready as well. That's, again, a very quick check. If button 1 go, although I probably should do, well, it's part of the ready check. So if button 1s are go, then we do these, which takes us a little bit. Then we send a packet and we receive a packet, and we do the outputs, and then we do the potentiometer outputs, and do some serial stuff if we request it. Butt scan just takes a look at our button to see whether or not any of the buttons have changed in the button register. And if they have, it sends out a packet. These are all very light in and of themselves. So I would chalk this up possibly to a problem with the LIN bus stuff not being tweaked just right. Well, we got rid of that serial print too. I don't think the serial prints really slow this thing down all that much, because they're all register based. But now we're not constantly printing every single loop. So there's a chance in hell that we actually get the shifter to work. There's still a couple tweaks with the buttons. Maybe some numbers got in there weird, because Lord knows I was fucking confused when I put it together. Let's just see where we are with it. Let's upload this to the Arduino. So COM8, Teensy 3.2, upload. Maybe we won't be ready for tomorrow. Do all our stuff. Everybody's getting up on the data thing, and then bam. Now we just have timing events and battery levels that are coming in. So if I hit a button, I think I see the button packets going through. They do seem a little slow, though. Yeah, the OK button doesn't seem to work. Oh, that's pretty fast. Except that it... Okay, when I push down the button, it triggers one on and off. Hold on a minute. Wow, it's, something weird is going on with the way it's sending the buttons. Well, that one's okay to be held down. Shift this. Shifter still doesn't work. Shifter still doesn't work. And certain buttons I'll press, and then they'll unpress. That one I can hold down now. It's really unreliable with this one. That's a timing issue. That looks like a timing issue to me. Yeah, all the buttons are discombobulated. That's a timing issue. Okay, let's see if we can solve the timing issue. So, turn this off again. Boop. See you later. I do wish I could flip it into test mode. Reset that so it's not frenetic. Okay, so timing is done by our LIN bus settings. And we could adjust a bunch of stuff. I mean, I could also enable some diagnostic stuff with the oscilloscope in order to get it up and running. Yeah, LIN bus should probably be a little bit more stable than this. I think maybe it's down to how we program this thing that makes everything a little bit woobly in terms of the signaling that it's sending in and out. So 11. Let's go up to like let's go up to 15 on that and see what happens for the half-bit timing. Of course, that's going to spread signals out a little bit more, I think. If I remember my LIN bus properly, was 11. Save. I don't want to lose my spot. Try again. Once I get the LIN bus stuff on lockdown, it's actually like locked down pretty nicely. Boy, it takes a while to initialize now, and the wheel freaks the hell out when it comes up. Yeah. So now nothing. Oh, I got that one. Those are starting to work a little bit, but they took a couple presses to get right. That one's still temporary, and it's off. Hey, I wish I could lock down the LIN bus's functionality properly, because it is all over the place, sure. What's happening is it's getting a timing, and then it uses that timing to figure out where the middle of that pulse is, and then it uses that middle timing of the pulse to get the rest of the signal. So we need to make sure that it gets to the right spot. We bit banged this. I didn't have like a LIN bus plugin for this sort of thing. It is getting every button press on the ones that are earlier in the packet. So what it's doing is it's drifting away from where it needs to be in terms of the timing. No, it's not ready for that yet. Not ready for that yet. Let's do like 8. Let's go in the other direction and see if we... Oops, wait. Let's go way in the other direction and see what happens. Really, the master is setting these timings for all the other devices. All the other devices are looking at the... it's a one-wire protocol, so nobody really knows how to get the timing right. So when we send the pulse, it sets it down for a certain amount of time and comes back up, and then all the other devices start paying attention to the next couple ones and zeros that come in. That's going to give it the timing that it needs in order to respond to whatever address is requested. And then it knows all of its timing. So, again. But, with a little bit of an application of offsets and things like that, we can get this right. That wheel knocking back and forth when it first configures is really creepy. Okay. Uh-huh. Well, that one took a second. That takes a little bit of time for these to recognize that a button's been pressed. That one didn't show up. That one's there. No, we're still bad. We're still bad, and we should feel bad, but it is closer. What about the one that was going weird? It was this one. Yeah, it's still going weird, right? Look at that. See what I mean? Like, so these are ones and zeros on a serial line, and when our timing is screwed up, I'm holding down one button. I'm just holding down a button. And so our ability to read what that button is doing, we're drifting back and forth around where we should be reading. We're not locked in. Are the predictions still going? I thought that was a no. I had it locked in before, but it's, timing being what it is. We've added a bunch of code to my code, and so stuff's a little bit less predictable. We did speed it up significantly, though. Well, it was 11 before. Let me take it to 10. No data, move on. How many bits to acknowledge a break? Milliseconds after a bad address. Wait for signal to rise or fall when reading. Let's upload this first. Let's upload 10. We'll put it back to about where it was. We'll see what we can do with this. Nothing else is really settings that'll affect this. Need to restart. I mean, I guess I should have it like be in a state where it's not doing serial on the other thing, so that we can tweak this and get this working. But this, I mean, we need a whole system test here. That's pretty stable. If I hold you down. Oh, see, it's gone in the other direction. Look at that. Press the button, release the button. Press the button, release the button. Press the button, release the button. Press, release. Push and release real quick. It's going the other direction now. So I think we're zeroing in on it. That's weird. I don't think 9 is the answer here, though. Maybe it's 12? I don't know. 12 is weird. Plus, these are microsecond timings, and I don't think it recognizes them exactly. I know Schmide was up in arms about this, because it doesn't necessarily recognize these timings the way that we think it does. I can put in 12.01, and it won't necessarily wait that amount of time. These are like, at this time scale, these are ticks of a clock that we're counting, and so every 4 ticks of a clock, we get something to happen. It might not translate to the number that we're putting in here. I mean, rise, fall 3. I don't think that's it. Let's try 12. This is all I can think to tweak is half bit. I mean, if I set the US per bit as a baseline, it should be 50. If I could give it more time and set it to be like 55, and then all the other devices will respond slower, which isn't a big deal. And then maybe our math turns out a little bit better. I mean, if I cancel all the serial commands and use a diagnostic checker to do them, maybe that'll pop it up to speed. Well, part of my code is that it doesn't use interrupts, which is probably part of the problem. Pressing and releasing one button sets off and unsets. How does that work? Is the teensy wandering that much? And the other part is that the shifter doesn't respond at all. Huh. Yeah, I mean, interrupts would probably be a way to help speed this up. It's just that my program is not doing a lot at this point. It really isn't. If I cancel all of the serial printing, will that speed up the program? Cancel the serial print, speed up the program. This is set at 11. Let's go like 25. Let's set it to actually be a half time, because maybe it's on the edge. Maybe that's what's going on. And I'll just try that out. Maybe I'll spend a little bit of tonight getting code out of here in order to speed up serial. Huh. Well, now it's just completely off. Oh, it kind of works. They work after I, like, press the button several times, which is completely unacceptable. Okay, that trigger works really well. It doesn't catch everything, though. It's very slow. Press, 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 press. It's not blinking. Press, hold, let go. Press, hold. Ugh. Press, hold. Press, hold. Press, hold. Press, hold. Press, hold. It's like we're at a different baud rate. It's unacceptable. Okay, so 20. Actually, I wonder if I can keep this running, if we'll just see the I don't think we'll see the output on this. Yeah, because none of the registers are set properly in order to let us do that. Okay, so I need to either restart this or look at the serial output. Serial output's going to be a mess. Serial output's going to look like this. Look at that. Look at it go. But it won't do anything with the buttons unless we get all of our registers set properly. We need to basically come up to speed and register ourselves as one of the modules, and then it'll work properly. So I will turn it on again. Beep, bop, beep. Look at all this configuration crap. I should add a press button to skip and have a routine that fills up all of those things, just so that I can observe when we get into the right operating mode. Oh god, it still sucks. It almost receives stuff properly, but not really. Wow, that's off by a major factor. So that was 20. Well, the next step would be 15, and we were already there. Go 16 just in case. 17 and 18 are probably outright. I don't know. I feel like maybe interrupts would have cleaned up this program. Bunch of output levels, nothing to everything. Huh? What do you mean? That doesn't... I don't think that makes any sense. Yeah, I'm gonna have to sit here and tweak numbers for a little bit. As fun as that is for you guys to watch. Usually there's a little bit of fiddling around with this, and then it starts working again. I could also just make it pull. Ooh. I could also just make it pull every time. I cry every time. No, wait, it does pull every time. Oh, come on, man. Beep. Beep. Yeah, it's some of the buttons are just... The pedals are very consistent. I think maybe when it gets out to the further ones, it's just out of whack. Huh? 0, 1, 2. Oh, you mean to make like different yeah, different observation levels of the system. All right, I'm gonna have to figure this out. I think what I'm gonna do. I'll tweak things a little bit on my own, and I'll see if I can figure it out. This right here, diagnostic pin of 6. I may do another define that has like a diagnostic, and basically what Schmide said, you know, and have different debug levels. So. And that way we don't have all the mess all over everything. I don't have to have, you know, stuff all over the screen when I'm trying to do this. I can have like an analog level, I can have like a LIN bus level, and then I can look at the packets and stuff like that. Buttons work. Yeah, oh yeah, you weren't here for the outcome. It didn't work at first. Then we flipped TX and RX, and then it worked. Except that button presses were extremely slow. I sped up button presses. Those are not quite where they should be, but they're faster. And now it's definitely down to a timing thing, because some buttons work very consistently, others don't. Some work very consistently, others don't. You're going to count that as working. I mean, I had to flip TX and RX, but... Ooh, nuclear fire burp. All right. That was very stressful, but we've made a hell of a lot of progress. I think all my code is in a place where it needs to be. I need to spend some time doing a little tweaking, messing about, making sure that everything works properly. I'm gonna move my monitor back up here so it feels more like I'm streaming. Ugh, my eyes are absolutely fucking destroyed. I need to take a break, and then I'll get back to tweaking around with this thing. I think I'll implement, I mean, if I was really actually functionally good at programming microcontrollers, I would program something that would take a command in order to change some of this stuff, because that would probably be a much easier way to do it. And if I had scope probe connections, I could also make this a little bit easier on me. Although technically, you know, maybe I could figure out, whoa, Chester Willard made a boatload of fart points. Gonna be the flatulence king. Okay, so I have a little bit of work to do. I need to sort out some of this stuff. I'm not gonna have a lot of time to work on it before next stream. I have a little bit tonight, and then tomorrow I have to like move furniture in the morning. So if I don't get back to you guys, it's because whoever I'm moving furniture with is really bad at time management. So you can blame them, even though I'm not going to tell you who they are. But we'll come back tomorrow. Depending on what I know, we could tweak this a little bit more and get it functioning for Saturday. If, like, you know, if an assistant flies out of the sky and does the rest of this job for me, we could play My Summer Car tomorrow. It's probably not going to happen. We you know, there's this tweaking, and like immediately when that's done, everything works perfectly from then on out. But there's a couple little strategies for the things that we need to tweak. I think this project has put much larger bags under my eyes, and I don't like it. I've been getting decent sleep lately as of a day, so we'll try again tonight, and I come back to you guys tomorrow. Hopefully I'm in good shape. But yeah, that's where we are with this thing. We're very close to done. And when we're done, we're going to play some games for like a couple streams, and then we'll get back into the swing of some of the other projects around here. I have a bunch to do, a bunch of interesting stuff to do, and I hope you guys can join me for it, because it's a lot of fun stuff. But thank you guys for the bits, especially. You got a lot of bits today just for joke numbers, and a lot of subs and quite a few gifts. I got 2 6-month gifts. That's insane. So enjoy those emotes, huh? I'm not really of a mind to raid somebody right now. I don't really know if anything's going on. I've mentioned what I'm talking about. I mentioned Turbo Nad, but he's not on yet. He waits until like 2 minutes after I'm on in order to go. So from there, your boy Damien's doing Elden Ring. If you guys want to check out Elden Ring, I don't know. It's like a gray game. Everything is just gray. But anyway, contacting vendors is nerve-wracking. Well, luckily we don't have to do that. But all right, I've got an idea of what I need to do. We made a shitload of progress today. We might get ourselves out of programming yet. We're this close. Then we put the hardware together, which I was just going to move everything over to the other desk, just pile it up, and it would work. But good day today. I will catch you guys on Friday, and we'll do something cool. Rabba's doing My Summer Car. There you go. If you guys want to watch some My Summer Car from a professional, check out Rabba's. Actually, I mean, we could, yeah, let's just raid him. He's probably going to end up playing something weird later on the night, but I'll just do this. We'll do that. We'll raid Rabba's. We'll just throw people over to his channel, because he is playing My Summer Car. He's probably going to stop and play like Tarkov, because he's got a problem. So just bear that in mind. And I will see you guys tomorrow.